All right, yes, hi class, very good morning everyone. Very good morning everyone, and welcome to the next session in the champion series and an important topic from engineering mathematics, linear algebra, where we are going to discuss. All right, yes, hi class, very good morning everyone. Very good morning everyone, and just a second, yeah. Okay guys, good morning Ghost, good morning Samukha, good morning Umesh, good morning Vinay, good morning Ashrita. All right, because many students were asking about mathematics, so I thought of bringing a session on mathematics. Okay, because earlier you have had the sessions on signal and systems controls, and of course other sessions like networks, electromagnetics, and many more subjects that will come up in the champion series in the upcoming time. Okay, so let us get started guys. Okay, by the time others will join, quickly share the session to all your friends and all the gate aspirants. Okay. All right, because this particular video, which is on linear algebra, we are going to cover 2021 to 2025 questions of all branches, because linear algebra is a crucial and important topic for all branches, and that is why you find several PYQs, all branches. Okay, so all branches PYQs I'm going to cover, so that this session is going to be a one-shot revision session for linear algebra. Okay, so let's get started. We'll directly start with the questions. Moving ahead towards the question, this is what the first question is. Right, this is what the first question is. Just a second, I think. Okay. All right. The first question. Now see, some questions of linear algebra are very fundamental. Have a look into this question. Have a look into this question. Okay. What is there in the question? Let A and B are two matrices given to you. Let det A and det B denote the determinants of the matrices A and B respectively. Which of the following options given is true? I think by this time option should have been there, because it's an easy one to start with. It's a GATE 2023 computer science 1 mark question. I've mentioned the mark of the question. I've also mentioned the branch. Okay, but I'm telling you, it's a common topic. It's good to practice all branch question, and if you have not done till now, all 5 years, all branch questions you can practice in this particular video. Okay guys, no answer yet, come on quickly. So what is there? You just have to see, okay, is there any relation between the given two matrices? Now you see here, okay, 1 2 3 4, the first row is different here, but the first row rather I'm able to see here. Okay, 4 1 2 3 is same. Okay, 3 4 1 2, the third row I'm able to see in place of first, and 2 3 4 1, fourth row is the same. So basically only two rows have been swapped. R1 is swapped with R3, and whenever two rows of a determinant are swapped, the determinant magnitude remains same, only the sign change will occur. Only the sign change will occur. That means the determinant of the matrix B will be just the negative of the determinant of A, and answer number B you can tick mark. Answer number B you can tick mark. Surendra Naik, correct answer. Okay, yeah, Shweta, it's not going to be A, it's B. Okay, the determinant will, magnitude will remain same, but sign definitely is going to change. Okay, next question. Next question, here it is. Let P and Q are two square matrices of same order. Now see, MSQ question, okay, 1 mark, direct property question. Direct property question. Yes, when a correct answer for the previous one was B. Yes. If P and Q are invertible, it is, what is invertibility? A matrix is invertible if its inverse will exist. Simple. And the inverse exists if determinant A not equal to 0. Okay, so what is this law? PQ inverse is Q. We all know that PQ inverse will go reverse as Q inverse P inverse. So this is correct. Similarly, QP inverse will also go reverse. That is Q inverse sorry, QP inverse will go reverse as P inverse Q inverse. This is correct, but the straight multiplication will not happen. PQ inverse is not P inverse Q inverse, and similarly QP inverse is not Q inverse P inverse. So what are the correct answers that will be able to match here? A and B. Okay, inverse of multiplication, direct property, 1 mark question. Okay, next one. This was a civil 1 mark MSQ question 2022. Next question, 2022 mechanical 1 mark question. Okay, have a look into it. Okay, yes, A and B correct answer. Surendra Nair, Ramu correct answer, A and B. Okay, have a look into the next question. Very simple. Okay, if the given matrix is a symmetric matrix, what is the value of K? So symmetry is about the diagonal line. Okay, this should be the line of symmetry, and elements above and below are same. If it has to be symmetric, elements above and below should appear same. So 2K plus 5 should be 3K minus 3. What is this? Solving, we get K equal to 8. Okay, how bonus of a question if it is, this is what it is. Option number A, 8. Next question. Consider a 3 cross 3 matrix A whose ijth element Aij is given by I minus j whole cube. Okay, what is the matrix A? So let's form the matrix. Okay, whose ijth element is given by, okay, I minus j whole cube. Correct. You can also take A equal to A transpose, Tirumila, but the simple logic is elements above the diagonal line are symmetric. That is what is the concept of symmetric matrix. Elements above and below the diagonal, they should be like mirror image of each other. Correct, na? Yeah. Have a look into this one, dear. Okay, so 3 cross 3 matrix whose ijth element. So if I have to form the matrix, dear, normally what is this matrix? Say 1, 1, 1, 2, 1, 3. Okay, first row, first column, first row, second column, first row, third column. When I say Aij, ith row and jth column, what will come up here? 2, 1, 2, 2 and 2, 3 element. What will come up here? 3, 1, 3, 2 and 3, 3 element. Correct. And what is this then equal to? What is this then equal to? Okay, so what is any element? I minus j whole cube. So 1 minus 1, 0. 1 minus 2, minus 1. Minus 1 cube is minus 1. 1 minus 3 is minus 2. Okay, minus 2 cube will be minus 8. Okay, now A2, 1. 2 minus 1 is 1. 1 cube is 1. 2 minus 2 is 0. 2 minus 3, again minus 1, but minus 1 cube. Minus 1. 3 minus 1, 2. 2 cube is 8. 3 minus 2, 1. 1 cube is 1. 3 minus 3 is 0. This is how it is. Okay, now you see all diagonal elements here are same. All the diagonal elements are not only same but 0. That is also important to identify skew symmetric matrix, but more importantly, elements above and below, okay, they differ in sign. Okay, elements above and below, when they differ in sign, okay, same magnitude but opposite sign, that is skew symmetric. Okay, option number B. GATE 2022 electrical 1 mark question it is. Correct? All right. All right, guys, 24 electrical 1 mark question. What is there in this question? Okay, see, some questions, 1 or 2 questions I'll keep giving you as homework as well. Why? Because only calculation part you can do. Na? Any doubt, you comment me right now only. What is there in this question? Which of the following matrix has an inverse? A matrix is invertible or a matrix has inverse if the determinant of the matrix is non-zero. Okay, if the determinant is non-zero, then you only have to verify which option will have a non-zero determinant. Which option is going to have a non-zero determinant? You get your answer. Okay, so this calculation part I leave to you. What you have to solve, I told you. The correct answer for which determinant not equal to 0 is going to be your right answer. Okay? All right? Correct. Yes, no, matrix has to be non-singular. Okay, when a matrix has non-zero determinant, it is also said to be non-singular. Okay, it is also said to be invertible. Okay, next. Okay, yeah, now coming to the real linear algebra question. So see, fundamental, some questions can come, but they will be, not very much expected, like basic question on determinant or symmetric, skew symmetric, like that. Okay, or basic product rules of matrix. Okay, but now coming to the real linear algebra question, where you see questions on rank, linear system of equation, and very, very important, eigenvalue and eigenvector. You'll find the majority of the questions from eigenvalues and eigenvectors. Okay, but we shall see that also. Starting with this one, come on. What is the rank of this matrix? GATE 21 civil 1 mark question. Okay, GATE 21 civil 1 mark question. Now see, dear, if you have to find the rank of this matrix, let's quickly review the rank definition. I want to take this as a review session as well, not only we just keep, non-stop solving the question. See, normally rank of the matrix, okay, rank of the matrix is the largest order of non-zero minor of the matrix. Largest order of non-zero minor of the matrix. Okay, or rank of a matrix is the dimension of column space of the matrix. Now this particular second point is only relevant to EC because they study column spaces, vector spaces in general. Okay, forget, let's come to the third important point that is applicable for all and that is important to solve the question. Rank is the number of linearly independent columns of the matrix. That is what also forms the column space of the matrix. Okay, so this in fact is a point which can help you solve many questions. The number of linearly independent columns of the matrix, or also equal to number of linearly independent rows of the matrix. Okay, number of linearly independent rows of the matrix. Okay, or otherwise rank is known as the largest order of non-zero minor of the matrix. At the same time, if you are not able to find dependency or independency, okay, you can comment on the largest order of non-zero minor with the help of row echelon form as well. Okay, so we'll come to some brief points about the rank, but come up here. Okay, this echelon form, on a safer side, you should always know it's a conventional and a true method of finding the rank, but not every time it might be required to you. Okay, I'll tell you why, because many times there's this observation of dependent rows and columns can help you solve the question, but you should always know this method. Okay, when a matrix is said to be in the echelon form, row echelon form, if there is any zero rows, okay, you can also call it as row of zero, okay, must be at the last. Okay, they must be below the non-zero row. So that means ROZ, if it is there, it must be at the last. Okay, and then number of starting zeros in each row must follow increasing pattern. Now, what is the meaning of this? Let me go back to the question and understand the point, and then some important properties about rank I will review here. Okay, look into this matrix. Okay, look into this matrix. I will help you to solve this question with the help of dependency also, and I will also help you to first understand the echelon form, because that is the official method. You should know it as a backup, not required for every question. Again, I repeat the same point. Okay, so what is the rank of this matrix? Civil 1 mark question it is. Okay, see. Row echelon form, you see here how many starting zeros. I'll define here. Suppose M is the number of starting zeros. Let me define a parameter. Let M be the number of starting zeros. Let M be the number of starting zeros. Okay, so how many starting zeros in this row? 0. Okay, but here I have a starting 0 which is equal to 1. Okay, so if this is 1, the next one has to follow increasing pattern. That's what I told you. Number of starting zeros must follow increasing pattern. But how many zeros here? Again, nil. There is no starting 0. See, this is not to be counted. What I clearly told, starting zeros. Okay, not any 0. The zeros at the beginning of the row. And again 1 here. Okay, no, but I have to follow. If this is 0, this is 1. This has to be more than 1. This has to be even more. Increasing pattern has to be there. Okay. So some answers have started coming up. Shweta says answer 3, Vinay says answer 3. Okay, we are going to match it up. See here, what is the first operation I am going to do? Let me target this and make it 0. Okay, so for that, what is this? This is -5 and the first element is 5. You cannot operate on element, but you can operate on row, elementary row operation I am going to apply. I am writing R3 as R3 plus R1. I am going to replace R3 as R3 plus R1. Elementary row operations will be applied. Okay, so what is the matrix then going to become? The matrix is then going to become 5, 0, minus 5 and 0. Okay, 0, 2, 0, 1. Only third row I have disturbed as of now. -5 plus 5, 0, 0 plus 0, 5 plus -5 again 0, 0 plus 0 is again 0. Okay, and then last row 0, 1, 0, 2. Okay, or in fact last row also I will modify within the same step. Na? What is there? Last row, see, I'll write down 2 operations here. What is the first operation I told you? I am doing R3 as R3 plus R1. In this step, I have not disturbed R2, so I can use R2 also. Okay, R4. Now see, this is 0. If I divide this 2, listen to me carefully. If I divide this by 2, it becomes 1. And then when you subtract 1 minus 1, here also you will get 0. Okay, here also you will get 0. Okay, so first divide this row by 2 and then subtract from the 4th row. Okay, so what I am going to do? I am going to do R4 as R4 minus R2 divide by 2. R2 by 2. So that this was anyway 0. This also becomes 0. 0 minus 0, 0. 2 minus half of 1. So that will be 3 by 2. Okay. Now see, there is a row of 0. Okay, but that is at the third place. I will send it at the last place. I will send it at the last place. Okay. Officially, okay, R3 I am going to replace as R4. R3, R4 replace. See, determinant sign will change, but no problem. I am only concerned with how many zero or non-zero rows are there. I am not concerned with the sign of the determinant as of now. Okay, so 5, 0, minus 5, 0, 0, 2, 0, 1, 0, 0, 0, 3 by 2 and 0, 0, 0, 0. Okay, now count the starting zeros. Okay, now count the starting zeros. Here there is nothing. Here I have 1 0. Here I have 3 zeros. Here I have 4 zeros. Okay, the number of starting zeros, they now follow increasing order. 0, 1, 3 and 4. Correct. It's clearly an increasing pattern. Yes, they are clearly following increasing pattern. That means the matrix is in row echelon form. In short, we call it as REF. The matrix is in row echelon form. Okay, if there is a row of 0, it must be at the last. Okay, so this is what I mean by row echelon form. And whenever a matrix is in row echelon form, rank of the matrix is given by number of dear is given by number of non-zero rows. The rank of the matrix, dear, is given by number of the non-zero rows. Okay, so how many non-zero rows? 1, 2, 3. The fourth row is 0. Out of the 3 rows are non-zero. Rank of the matrix will be 3. Number of non-zero rows for this current matrix is 3 when the matrix has been converted into row echelon form. Yes. So B answer, that is matrix rank is 3, is the very correct answer. Okay, is the very correct answer. Okay, is the very correct answer. Okay. All right. Now you see here, one more thing. Let us do simple one more thing here. Okay. What can be one more thing here? What can be the one more thing here? Now let me, for that one more thing, let me just copy the matrix once again. Correct. And now look into it. Okay. Now look into it. Okay. R3 and R1 are clearly dependent. R3 is negative of R1. Okay, 5 becomes minus 5, 0 is 0, minus 5 becomes 5, 0 is 0. R3 is minus R1. We can say like that. The first and the third row are just opposites in sign. The first and the third row are just opposites in sign. Very clear to everybody? Okay. Now see, the second row cannot be related with first because 5 you cannot convert to 0. Okay, 5 into anything will not be 0, na? Okay, only 5 into 0, but if it is 5 into 0, then 0 into 0 should also be 0. So no, there is no relation between R1 and R2. R3 and R1 are related, correct. Similarly, again, R4 and R1 also not related. You cannot anyhow convert 5 to 0. Okay. So that means there is only one dependency I am able to find. Okay, R3 is negative of R1. That means there is one dependent row. How many? There is one dependent row. Okay. So how many out of the 4? It's a 4 cross 4 matrix which has 4 rows. One of the row is dependent. So how many independent rows? How many independent rows? Okay, 3. Okay, so rank of the matrix RA, or sometimes you will also find the rank represented as row A, depends on books to books. The rank of the matrix RA or row A is equal to 3. Got this point? The rank of the matrix is 3. First I have solved by echelon form and then I have explained you simple by dependency. Okay, simple by the dependency. Any doubts in this one? Good morning, Ajay. Okay. Chalo. Okay, any doubts you please mention. The correct answer is rank equal to 3. Now I am telling you, suppose there was one dependent row. Okay, or suppose understand like this. In the row echelon form, by chance, if the last row was also non-zero, then the rank will be 4. Na? Rank will be 4 only. Na? Number of non-zero rows. Okay, but can the rank of this matrix be 5? Not at all possible. The maximum rank of this matrix can be 4. Okay. Now, in fact, if I had checked the determinant of this matrix, I did not check because 4 cross 4 determinant will be time taking. But suppose, what if the determinant of the matrix was non-zero? If, here it will be 0 because you have an entire row of 0. Okay, but if the determinant was non-zero, then what will you say? That there is a 4 cross 4 determinant. There is a 4 cross 4 minor, okay, which is non-zero. And if there is a 4 cross 4 non-zero minor, rank will be 4 also. Because what is the first definition of rank? I told you, largest order of non-zero minor. Okay, so if the determinant of the matrix itself was non-zero, here determinant will be a 4 cross 4 determinant or a 4 cross 4 minor. So you will directly have a 4 cross 4 minor non-zero, rank will be 4. Okay, so maximum possible rank of this matrix was 4. If determinant was non-zero, rank will be 4. Okay, now listen to some important points you should always know about rank. Okay, if the matrix is a square matrix of size n cross n, rank will be always less than equal to n. That means maximum rank of the matrix is n. If it is a non-square matrix of size m cross n, the maximum rank depends on the minimum of mn. Why? Because suppose if I tell you there is a 3 cross 5 matrix. Okay, what is the maximum minor you can form? The 3 cross 5 matrix, the maximum minor you can form is a 3 cross 3 minor. You cannot add a row. Okay, so what is the maximum minor? 3 cross 3. If that is non-zero, rank will be 3. Okay, so what is the maximum rank for this? Maximum rank will be 3. Okay, so maximum rank depends on whoever is smaller out of m or n. Okay, now whenever the matrix has the maximum possible rank, whenever the matrix gets the maximum possible rank, it is said to have full rank. It is said to have full rank. Like previous question, the matrix is a 4 cross 4 matrix. Okay, the matrix here is a 4 cross 4 matrix. Okay, but is the rank of the matrix equal to 4? No, the rank of the matrix is 3. That means the rank is less than 4. Okay, and because the rank is less than 4, it is not full rank. What is full rank? If the rank of the matrix by chance came up as 4, then you will call it as full rank. Okay. Okay, now when will a square matrix have full rank? I told you, if the determinant was non-zero, then you would have got rank 4. Okay, so when it is non-singular, again I repeat, when the matrix has non-zero determinant, then it will always have full rank. Then some more points. Okay, you should note down. Identity matrix will always have rank n, full rank. n cross n identity matrix. Null matrix can only have the rank 0. All minors are 0. Okay, for real matrix, rank of A and rank of A transpose, or rank of AA transpose, rank of A transpose A, all these will be same. Okay, all this will be same for rank of AB. Now see, these last 3-4 points are not expecting any numericals, but sometimes directly MSQ questions, they are asking properties directly, as we saw in the basic part also. So you should be just knowing it. Rank of A into B less than equal to minimum of rank A rank B. Rank of A plus B always less than equal to RA plus RB. Rank of A minus B greater than equal to RA minus RB. Okay, rank of a diagonal matrix will always be equal to number of non-zero diagonal elements. Okay, number of non-zero diagonal elements. Okay, so finally, yeah, correct. For a diagonal matrix, that was the point. Okay, rank of adjoint A, if they wanted to ask rank of adjoint A, if rank of A is a full rank, the rank of adjoint A will also be full. If rank of A less than n minus 1, rank of adjoint A will be 1. If rank of A less than n minus 1, rank of adjoint A will be 0, because in that case, in this case, the adjoint A itself will be a null matrix. Okay, so now I don't want to go into the derivation of all these points, because I want to take all the PYQs of 5 years, and as I've told you, I'm taking all branches. Okay, that is why question and solving the question is more important rather than deriving any property here. Okay, so echelon form I explained you. Now next question, GATE 2022 instrumentation MSQ 1 mark question. Okay, come on. What the question is, M is 2, 3, 7, 6, 4, 7, 4, 6, 14. Which of the following statement is or are correct? Rank. Come on. Now, very clearly you can see a relation. Okay, 2 into 2, 3 into 2, 7 into 2. Matched. Okay. I again repeat, 2 into 2 you will get 4, 3 into 2 you get 6, 7 into 2 you get 14. So what is the correct observation? That the third row is directly obtained by multiplying the first row by 2. R3 is 2R1. R3 is directly 2R1. Okay. But the second row would not be dependent. 2 into 3 is 6, but 3 into 3 is not 9. Okay. So R3 is 2R2. So, the rank cannot be the determinant. See, one more point. I'll stop here and tell one more point. Whenever the rows are dependent, the determinant of the matrix is also 0. This is also a determinant property you should know. Okay. So that means the determinant is definitely 0 because there are dependent rows. Okay. How many dependent row? One dependent row. Okay, dependent row means determinant, the name of the matrix, determinant is 0. Okay, so matrix cannot have full rank. What is the rank of the matrix? The rank of the matrix M will not be 3. The rank of the matrix will be 2. Okay, why? Because Okay, if there is one dependent row, there will be two independent row because it is a 3 cross 3 matrix. There will be two independent row. Okay, or you can say one more thing, or if you want to tally rank 2, it's a very easy thing. Okay, what do you mean that the matrix has rank 2? There should be at least a 2 cross 2 non-zero minor. Okay, how much time does it take to check a 2 cross 2 minor? Okay, suppose if I feed these numbers, okay, 2, 3, 6, 4. See this value? This is 8 cross multiplying minus 18. Net answer non-zero. 8 minus 18 is non-zero, so the rank is 2 because you have a 2 cross 2 non-zero minor. Because you have a 2 cross 2 non-zero minor, rank will be 2. Okay, so rank cannot be 3. Okay, the rows are linearly dependent. Yes. Okay, so which of the options are correct? Rank is 2. It is not 3. The rows are dependent. Yes. And the determinant is also 0. You can separately calculate determinant, but you should know if the rows or columns are dependent, determinant will be 0, 100%. Okay, so A, C, D, 3 answers are correct here. Correct, Shadow. Correct, Tirumala. 3 answers will be correct here. Okay. Nanendra, just check it out once. Okay. Shrigidi also check it out, not A and D. C also, na? Of course. Okay, if the rows were not dependent, that means all the rows are independent. If all the rows are independent, then determinant should be non-zero. Rank will become 3. Okay. So A and D automatically C is correct here. Okay, so A, C, D, 3 answers correct for this MSQ question. Okay. Yes, Vinay Pratap, C also correct, na? Correct. Next question. The rank of the matrix given below is 1. It's a very simple question for 2 marks. Very simple question for 2 marks. Okay. What is the ratio alpha by beta? What is the ratio alpha by beta? The rank of the matrix A given below is 1. What is the ratio alpha by beta? Come on. What is that ratio alpha by beta? We have to figure out that ratio. The rank of the matrix is 1. The rank of the matrix is 1. What is the ratio alpha by beta? Let's check it out. Let's check it out. Now, rank is 1. That means all 2 cross 2. See, it's a non-square matrix. Sorry. 3 cross 2. 3 rows and 2 columns. Maximum rank could be 2. Because it's 3 cross 2. Na? The rank cannot be 3. Rank depends on minimum of Mn. So, maximum rank is 2. Okay, but they are telling rank is not even 2. Rank is 1. Okay, if rank is 1, that means the rank of the matrix A is not even 2. Whereas what I am telling you, the maximum possible rank could have been 2. Okay, 3 is not at all possible, but the rank is not 2. Rank is not 2 means simple logic. All 2 cross 2 minors will be 0. All the 2 cross 2 minors will be 0. Okay. So you can get the value of alpha beta directly. All the 2 cross 2 minus will be 0. What is this? The first 2 rows if you take here 1, 4, minus 3 and alpha. This should be 0. Okay, so that means alpha minus plus 12. Alpha plus 12 is 0. Alpha will be minus 12. Okay, then first and third row. 1, 4, beta 6 is 0. This will give you 6 minus 4 beta equal to 0. That means beta will be 6 by 4 or 3 by 2. Okay, so what is alpha by beta? I would say simple one for 2 mark. Minus 2 divided by 3 by 2. So minus 24 by 3. Minus 8. Fill the answer. Minus 8. Yes, Shadow correct answer. Ramu correct answer. Yes. Answer is minus 8. The basic points, if you know, sometimes you are able to crack the questions easily. Okay. Simple logic it is to get to this answer. Next question then. What is this? GATE 2025 instrumentation 1 mark question. Again a question on rank only. A 2n cross 2n matrix A equal to Aij has its elements as Aij equal to minus beta or plus beta based on the value of I plus j. Okay, I plus j. Yes, Tirumala also correct answer. Nanendra correct answer, minus 8. Okay, now see, if I plus j is even, the element value is minus beta. I plus j equal to what? Element value is beta. Okay, where n is any integer greater than 2. Okay, n is greater than 2. So 3, 4, 5, any value. Let's try the simple value of n equal to 3. Okay, let us take n equal to 3. Then the matrix will become, the matrix size is 2n cross 2n actually. The matrix size is 2n cross 2n. Okay, that will become 6 cross 6 actually. What is that matrix? Now see, what will I write here? A 1 1 na? Okay, what is 1 plus 1? 1 plus 1 will be 2. And 2 is even, and whenever you have even, I plus j equal to even, you will write down the answer as You will write down the answer as minus beta. Whenever I plus j is even, write down the answer as minus beta. Okay. Now remember, next will be just alternate only, because if 1, 1 comes here, next will be 1, 2, 1 plus 2 odd, 1 plus 3 even. The odd even will alternate only, na dear. What is there? Odd even will alternate. Okay. So if the first element is minus beta, next will be plus beta, then minus beta, plus beta, minus beta, plus beta. 6 elements because we have 6 columns. Okay. Now, if this was A1, 1, this will be A2, 1, second row, first column. 1, 1, 1 plus 1 is even, 2 plus 1 again odd. So even if you go column wise, okay, even if you go vertically, if you start with even, next will be odd, next will be 3 plus 1, again even. So here also odd even will alternate na. Here also the odd even will alternate. Okay, so what is this value? If this is minus beta, so plus beta, then okay, let me first complete this column. Minus beta, plus beta, then next minus beta, again plus beta, next is again minus beta and plus beta. Now complete every row by alternate only. If this is beta, then minus beta, beta, minus beta, beta and minus beta. Any doubt you can mention here. Okay, fourth row. Fifth row. Sixth. Right. Tirumala has come up with the answer equal to 1. Okay. Now you very clearly see, all the rows are actually proportional to each other. All the rows, if you call this as how the matrix structure is, if the first row I name it as R1, the next row is minus of R1. Okay, now first, third and fifth are same, R1 and here also R1. But second, fourth and sixth, they are also same and they are minus of R1, minus of R1. This is what it is. Okay, R1 minus R1, R1 minus R1, R1 minus R1. Okay, all the rows are dependent actually. Okay, all rows are proportional. All rows are identical, or you can say proportional to each other. Okay, or you can say only one independent row. Okay, everything else depends on R1. Okay, so if there is only one independent row, rank of the matrix is 1, finish. Rank of the matrix. No, it cannot be 0. See, only hello. Yes, guys, audio will now be there. There was the battery issue, but now okay. Okay, we shall continue then. Answer for the question was 1. Okay, we shall now continue with the next question. Okay, GATE 2025 easy 1 mark question. Okay, consider this matrix given for which of the following, for which of the combinations of alpha, beta and gamma is the rank of the matrix at least 3. is the rank of the matrix. You want the rank of the matrix at least 3. This will happen for what value of, or what combination of alpha, beta, gamma. Okay, for what combination of alpha, beta and gamma. Okay, now understand this is again important conceptual question. Easy, only 1 mark, but a conceptual question. Yeah. All right. Okay. Now number one thing is, see, if I just count the number of starting zeros, okay, if I just count here the number of starting zeros, what is going to happen? Just a second, hai na? Let me just take this matrix for a second. Okay. Let us talk about this matrix. Any answer you have by chance till now, you can let me know. Why is that not coming? Just a second. I think that, okay, no problem. I'll write it only. I think that is lost, but no problem. Where is that combination coming up? Here it is. Okay, I'll just directly take it here. Okay, so 2, 3, 4, 5. Then you have 0, 6, 7, 8 and 0, 0 alpha, beta, 0, 0, 0 and gamma. This is what is the matrix given. Okay, now number one, it can directly be, okay, it can directly be in the row echelon form if, okay, see, let me count the number of starting zeros. Number of starting zero is nil here. Number of starting zero, same m, I'm not repeating what is m, number of starting zero, this is 1. Okay, here the number of starting zero is at least 2. Okay, is at least 2. Okay, is at least 2, and here the number of starting 0 is at least 3. Okay, is at least 3. Here it can be 2 or more. Okay, but what if alpha, beta, gamma, all of them are non-zero? Okay, the number of starting rows, number of starting zeros here will be 2 only. Here will be 2 only if alpha not equal to 0. If alpha not equal to 0. Okay, forget beta. Okay, because only starting zeros are counted. So if alpha not equal to 0, you get the starting number of zeros as 2 here, and this number of zeros is anyways greater than equal to 3. Okay, anyways greater than equal to 3. So here also I'll write down, I'll split into condition. The number of starting zeros will be 2. Okay, if alpha not equal to 0, it will be 3 if alpha equal to 0, beta not equal to 0, and it can be 4 also. Okay, if alpha, beta are both 0. Okay, what about m here? M will be 3, the number of starting zeros, if gamma equal to 0, if gamma not equal to 0, and if gamma also 0, the number of starting zeros will be 4. This is a description of the matrix given. Okay, now, okay, first condition, alpha 0, beta gamma not equal to 0. Alpha 0, okay, beta gamma non-equal to 0. Okay, but yeah, if beta and gamma not equal to 0, they can be related, na? Okay, you can anyways write down gamma is equal to how much? You can always write down gamma as gamma by beta into beta. Okay, because all the other elements are 0, so 0 equal to 0 always will satisfy. That means the fourth row can be dependent. The fourth row can be dependent on the third row in this case. In this case, okay, or one more thing you can do. Okay, one more thing you can do. Suppose if alpha is 0, okay, if alpha is 0, beta and gamma are not equal to 0, then what happens? Okay, you can convert by the row operation. What is that row operation? R4 equal to R4 minus gamma by beta times R3. If you do this, this also will be 0. Now the matrix will be in echelon form. Okay, rank is number of non-zero rows. How many non-zero rows? 3. Okay, so in this case, the rank of the matrix will be equal to 3. In this case, the rank will be equal to 3. And that is what I want. I want the rank at least 3. Which of the condition? Now, if alpha, beta, gamma, everything is 0. If alpha, beta, gamma, everything is 0, 0, 0, 0. Okay. 0, 0, 0. Then also you have echelon form. Okay, number of starting zeros 0, 1, 4, 4. Anyways, there cannot be more than 4 zeros. Okay, how many non-zero rows now? Only 2 non-zero rows. Only 2 non-zero rows. So rank will be 2 here, and that is what I don't want. Rank will be 2. I want the condition where rank is at least 3. Okay, next case, beta, gamma 0, but alpha. Okay, this alpha itself is non-zero. Suppose if this is non-zero, suppose this is 2. Okay, then how many starting zeros? I told you, na, the other page I explained you. This is 0, 1. This is only 2 starting 0 and gamma is 0. So this is 4 starting 0. That means increasing pattern only. Okay, increasing pattern means row echelon form, and you have how many? This is 0. How many non-zero rows? Up to here non-zero rows. Beta also 0, no problem, but this is non-zero row. How many non-zero rows? 3. Rank will be equal to 3. Rank will be equal to 3. Okay, last condition. Last condition. Okay, alpha, beta, gamma, all of them are non-zero. Alpha, beta, gamma, all of them are non-zero. But here, okay, again, alpha, beta, gamma, all of them non-zero means what? At least alpha non-zero, na? Okay, this is non-zero. This is something like 2. Okay, this is something like 2. Here, gamma also non-zero. Okay, this is also something like 4. Any value you assume. Okay, starting 0, 1, then 2, and then 3. Okay, row echelon form, and all the 4 rows are non-zeros. All the rows are non-zero, rank will be 4. This is also I want. I want rank at least 3. Okay, so rank will be 3 in the first, third and fourth condition. Okay, first, third and fourth condition. That is answer A. Answer will be A. Answer will be A. Okay. Answer will be A. 1, 3rd and 4. Yes, Shadow correct answer. Shweta correct answer. Okay. Yeah. So 1, 3 and 4. So this is a basic analysis question. A little better question as compared to the previous ones. Okay. But still not difficult. You just have to have that basic analysis. Yes, Nanindra correct answer. Tirumala correct answer. A is going to be what is the correct answer. A is what is going to be the correct answer. Okay. Now, gate 21 IN 1 mark question. Next question, here it is. Consider the row vectors 1, 0 and W is 2, 0. What is the rank of the matrix 2? Okay, let's form this matrix. What is there? Easy one, na? Okay, 2, V transpose. Now, V is the row matrix. V transpose will be column like this 1, 0 and 2V 1, 0 plus 3 times W transpose. What is W transpose? 2, 0 and W is this 2, 0. Okay, what is this then equal to? Now, you know how we will multiply first row with first column. 1 into 1 will be 1. Okay, so this will be 2 times, to see, this is going to be 1 into 1, 1, then 1, 0, 0, then second row first column, 0 into 1, 0, 0 into 0, 0, plus 3 times, here 2 into 2, 4, correct na? This is what is given, yeah. Next, 2 into 0, 0, 0 into 2, 0, 0 into 0, 0, finish, just add the numbers. Okay, just add the numbers. So the matrix M is now equal to, this will be 2, this will be 12, 14. But rest, this is all 0. 2 into 0 also will be 0. Here also all 3 0. So all these 3 elements are 0. Okay, what is the rank of the matrix now? Finished, na? Okay, it's a 2 cross 2 matrix. Can the rank be 2? No, the determinant will be 0. The determinant is 0. Okay, the rank cannot be 2. Rank cannot be 2. Rank of this matrix is simply 1, because at least there is one non-zero element. Okay, there is at least one non-zero element, means there is 1 cross 1 minor which is non-zero. The rank is equal to 1. Correct answer B. Correct answer B. Yes. Correct Shrigidi, correct Ramu, correct Shweta, Jai Prakash, Surendra Naik. Correct answer B. Okay. Okay. Yeah, that is what is the correct answer. Okay. All right. Again, 1 mark question. Okay, one question as homework for you. Take this one question as homework for you. What is there in this question? A matrix M is constructed by stacking the 3 column vectors V1, V2, V3. Okay, so 3 columns as options are given. You have to form the matrix by arranging the vectors as column. Choose the set of vectors, okay, from the following options such that rank of M equal to 3. Okay, rank equal to 3. Rank equal to 3, that means use the simple logic, determine, see, choose, you can choose 2 paths here, rank equal to 3, Okay, choose the logic that determinant of the matrix should be non-zero, or choose the logic that all three columns, that is V1, V2, V3 are, all the three columns are linearly independent. Then only the rank is 3. Okay, linearly independent, right? Now see, some hints also I'll give you. When you form the matrix, this is entire column 0, determinant 0. So this cannot be the answer. Okay, this cannot be the answer. Okay, entire column C3 0, the determinant is 0. The determinant is 0. Okay, option number D, if I show you, when you add now 1 plus 0, 1. 0 plus minus 1, minus 1, 1 plus 0, 1. Okay, so here column number 3, okay, or V3 equal to V1 plus V2. Dependency is there. Dependency is there. Okay, I told you dependent column should not be there. Okay, so here there is dependent columns, not allowed. Okay, so B cannot be the answer, D cannot be the answer. Choose from A or B. This much hint I have given to you. You only have to confirm whether it is A or B. This much hint also I have given to you. Okay, just confirm A or C. From A or C. B or D cannot be the correct answer. Okay, so that is the homework. Okay, this part I'll keep this as homework. Okay, whether it is A or C. Whether it is A or C. Next question. All right, system of linear equation coming up here. Okay, next question. Gate 25 doubly 1 mark question it is. Let A and B are given to you. What is the system of linear equation has? Okay, infinite, many solution, finite number of solution, no solution, or a unique solution. Okay, which of the condition will satisfy? Which of the condition will satisfy? See, either it will have a single solution, more than one means infinite solutions only. It cannot have a finite number of solution like 5 or 10, that is never possible, or either it will have no solution. Okay, right, B is just a randomly created option. Now, what is the official theory and then the procedure? I told you, I want to keep the theory part brief and more on problem solving techniques like rank also. Okay, majorly the dependency or determinants are important. Otherwise, echelon form also we have used in some question. Okay, so background also we know and techniques of solving the question also we know. Now, whenever there is a linear system of equation like this given Ax equal to B, okay, some 3 equations are given where we arrange the coefficients of x, y, z in the matrix A, B1, B2, B3, right side coefficients in some matrix B, and x, y, z is the vector of unknowns. What is the vectors or what are the values to be calculated? We call the system of equation as Ax equal to B. The system is consistent or solvable. Out of this now we call the matrix A as the coefficient matrix. Okay, A is to B, the augmented matrix. Okay, whenever the B matrix is included as a extra column, that becomes the bigger A is to be augmented matrix. Okay, so the Rauche-Capelli theorem says that the system is consistent. Consistent means, okay, solvable. Consistent means solvable. If it is solvable, it will have one or more solution. Minimum one solution it may have. Okay, the system is solvable or a system is consistent if the rank of coefficient matrix is equal to the rank of augmented matrix. Okay, I will write down all the entire conclusions within this flow chart. Okay, suppose Ax equal to B. Okay, and the rank of A equal to rank of A is to B, and suppose both the ranks are equal to R, then the system is consistent. That's what Rauche-Capelli's theorem says. But if rank of A not equal to rank of A is to B, then what will you say? If rank of A not equal to rank of A is to B, then the system is inconsistent, means not solvable. Inconsistent means no solution. Inconsistent means no solution. Okay, but if it is solvable, how many? One or more. It may have a one solution, that is unique solution, or it may have more than one, means infinite. Okay, if both the ranks are equal and equal to n, where what is n? N is the number of variables. Okay, n is the number of variables. Okay, then the system of equation has unique solution. Okay, if both the ranks are equal but less than the number of variables, okay, then the system will have infinite solution. Okay, will have infinite solution. Okay, now one more thing I will add with infinite solution and no solution. What is that one more thing? Okay, what is that one more thing? I'll come up first with the unique solution. Okay, unique solution. Okay, suppose A is a square matrix. One more technique I'm telling. See, what is a unique solution? Unique solution means rank of both of them are equal and equal to n. Equal to n. Okay, so that means rank of A also equal to n. Okay, so unique solution is rank of A equal to rank of A is to B equal to n. Okay, so that also means that the rank of the matrix is n. Okay, now what if A is a square matrix? Usually which it will be if it is a square matrix. If it is a square matrix. See why I am telling if it is a square matrix. See what will happen if it is not a square matrix. Good afternoon Manasvi, I am fine. How are you? Okay, answers have already started coming up. Many of you say answer as infinite solution. See, I am telling A as a square matrix. See here. What is the matrix A here? What is the matrix A here? Okay, A here is a 3 cross 3 matrix. When I took 3 variable and 3 equations. Understand how many rows the matrix will have. How many rows the matrix will have? It has the number of rows corresponding to number of equations. Okay, first row, first equation, second row, second equation, third row, third equation. How many columns it has? Okay, columns are the number of coefficients in every equation. How many coefficients? How many variables you have? For every variable you have a coefficient. Na? So you have 3 variables. So that is why 3 entries, 3 columns. Okay, right. So generally, if by chance a non-square matrix come, that will come when you have number of equations not equal to number of variable. Okay, suppose A is a m cross n matrix. Okay, what will be m, what will be n? M is always equal to number of equations. How many rows? 1 row for every equation. 1 row for every equation. Okay, how many variable? Or how many columns? 1 column. Okay, for every variable. Okay, so m cross n, number of equations cross number of variables. Okay, so yeah, coming back to the unique solution discussion, what I'm telling you, if A is a square matrix, okay, what is the condition for the matrix to have rank n? We know that for a square matrix to have full rank, n means full rank. For a square matrix to have full rank, it should have non-zero determinant. It should have non-zero determinant. Okay, that is a simple logic you can apply. So if the question is concerned on unique solution, let's create some shortcuts here. Okay, unique solution, determinant A not equal to 0. Okay, if A is square, if it is not square, then we will think about rank only. Okay, then infinite solution is always related with dependent equations. I don't want to prove it again, but I will explain you with question. Okay, whenever the equations are dependent, okay, the system of equation will have infinite solution, and whenever the equations are contradictory in nature. Okay, contradiction in equations. Contradiction means they don't agree to each other. Okay, they don't agree to each other. Okay, if one correct, the second equation is wrong. Okay, then that is the case of no solution. Okay, I will explain you another example first, then we will go back to the previous question. Have a look into this question. Okay, by these simple logic, you will be able to solve the answer rather than every time going to the rank or determinant calculation. Now see here, gate 22 EC 1 mark. Okay, system of linear equation AX equal to B, where A and B are matrices given. Let me write down the equation. Okay, now see, what is the type of matrix given? 2 cross 3. That means there will be 3 variables but only 2 equations. 3 variables but only 2 equations. We call it as underdeterminant, because for 3 variables you should have 3 equations, but no problem. Let me write down the equation. What is going to be the first equation? These are what? These are the coefficient of x, y, z. That means x minus root 2y plus 3z equal to how much? Equal to b1. What is the first constant on the right side? Is 1. Second equation, minus of x plus of root 2y minus of 3z equal to 3. Okay, now listen to me very carefully. Okay, no need to go for any rank calculation if you have just observed the numbers here. What will I simply say, dear? Okay, if equation number 1 says that x minus root 2y plus 3z is 1, automatically what you should say, what is the value of minus x plus root 2y? From your side, forget that there is any second equation. From your side you write down. Okay, what is the value of minus x plus root 2y minus 3z? That is minus 1. What I have just done is I have only taken negative of the equation 1. That tells me minus x plus root 2y minus 3z is minus 1. But the same information by the second equation. Okay, second equation says that minus x plus root 2y minus 3z is 3. That is what I mean by contradiction. Who is right? Minus x plus root 2y minus 3z. Whether it is 3, whether it is minus 1. Okay, according to equation 1, it should be minus 1. According to equation 2, it should be 3. It's like clash. It's like a fight. Contradiction. That is what I meant by contradiction, when they don't agree to each other. Okay, one says something which the other don't agree. Okay, that means if one is correct, second is false. If second is correct, first is false. Simple. Okay, so it is a contradiction case, and in case of contradiction, you get no solution. In case of contradiction, you will not get any solution. You will not get any solution. Simple. Simple. Finished. Otherwise, if you wanted to solve it, now see what will happen. See, I'll tell you that also. See, I wanted it to be actually a 1 mark question, and this is what is simply the logic of solving a 1 mark question without going into detailed theorem and computations, right? See what will happen if you solve this. Okay, if you solve this, what is the A is to B matrix? See here, simple. 1 minus root 2 and 3, and this was minus 1 plus root 2 minus 3. This is 1, this is 3. Now you see here, this much part is A na. In this much part you can directly say R2 is minus of R1. These two are just opposites in sign. Now this is the A matrix. R2 is minus R1. Okay, that means if there is one dependent row, if there is only one dependent row, so only one independent row out of 2 rows, because only 2 rows are there, only one independent row. So what is the rank of A? 1. Rank is number of independent rows. Now the rank of A will be 1. Okay, but now rank of A is to B. You directly check this minor. You check this minor. What is the value of this minor? Okay, 339 minus of minus 3 plus 3, net answer non-zero. And if you have a 2 cross 2 minor which is non-zero, the rank of the matrix, which matrix? The bigger A is to B matrix will be 2. Correct, na? If you have a 2 cross 2 non-zero minor, rank will be 2. So that means what is the condition here? Rank of A not equal to rank of A is to B. That is what is no solution. The system is inconsistent. That is what I have shown you in the table also. That is what I have shown you in the table also. Rank of A not equal to rank of A is to B. But by just basic observation of numbers, you could have commented no solution. No need to entirely solve it. Got the idea? I am still solving it just to, show you the method. But this is what actually requires to, solve many questions where numbers are, easily identified. And in many questions it will happen. Otherwise, always the backup plan is ready. Okay, but the shortcuts are always important. The techniques are always important. Yeah, let me go back to the other question. I started with this question. Here it is. Okay, GATE 25 EE 1 mark question. GATE 2025 EE 1 mark question. Have a look into this. Have a look into this. Now, what is clearly happening is, if I convert this to the equation, see, x plus y plus z is 1 by 3. Okay, next equation, minus x minus y minus z is minus 1 by 3 automatically. Third equation, there will be no x, 0 coefficient. Y minus z is 0. Okay, what is happening in the 3 equation is, you can say that equation number 2, okay, is just negative of equation number 1. It is not a contradiction. It is not a contradiction. See, if x plus y plus z is 1 by 3, automatically you can say minus x minus y minus z is minus 1 by 3. This is not a contradiction. It is automatically true. That means second one is not required. I mean, second one is not a real information. It is a copied information, dependent information. It is already known to me. Okay, so you have dependent equations. You have dependent equations. So the system of equation will have infinite solutions. As far as exam is concerned, you should solve by this method. Option number A. As far as exam is concerned, you should solve by this method. Okay. But if again, just as for concept clarity, if I take the A is to B and show you the full calculation, what is the A is to B? 1, 1, 1, 1 by 3. Minus 1, minus 1, minus 1, minus 1 by 3. And 0, 1, 1, sorry, 0, 1, minus 1. And 0. See, what I am first of all going to do is, in this, simply make the R2 as R2 plus R1. Make the R2 as R2 plus R1. Okay, or rather I can swap the equation also, na? Whatever equation is first or second or third doesn't matter. I will write down, I will first write down the third equation, 0, 1, minus 1 and 0. And then minus 1, minus 1, minus 1 and minus 1 by 3. So that directly I get the row echelon form. Okay. Now I'm going to write down R3 as R3 plus R1. Okay. First equation, third equation, second equation, like that I have arranged. Okay. Now you see here, when R3 is added as R3 plus R1, what is going to be the matrix left in front of you? 1, 1, 1, 1 by 3. Second also I am not disturbing, 0, 1, minus 1, 0. Third, R3 plus R1, minus 1 plus 1, minus 1 plus 1, minus 1 plus 1. Minus 1 by 3 plus 1 by 3, 0. Everything is 0. Now you see, is it in the row echelon form? Yes. Starting 0, 1, starting zeros, up to here 3, up to 4. That means clearly row echelon form has been obtained. Number of starting zeros are increasing order. Okay, are in the increasing order. If there is a row of 0, that is at the last. Everything is as per row echelon form. Okay, what is the rank of the matrix A? In echelon form, the rank is number of non-zero rows. Number of non-zero rows of A. Okay, A means up to this much. A means up to this much. But for A also, third row is 0. Only first two rows are non-zero. Okay, what is the rank of A is to B? Because remember, up to here is the A matrix only. Okay, now A is to be the full matrix, but for the full matrix also third row is 0. For the full matrix also the third row is 0. So how many non-zero rows of A is to B? They are also equal to 2. Okay, so they are same. Rank of A is equal to rank of A is to B. Both of them are equal but less than the number of variables. Both are equal but less than number of variables. That is what I told you here. That is what I told you here, infinite solution. That is what is the meaning of infinite solution. Both of them are equal but less than the number of variable, infinite solutions. But how I originally solved the question? By the dependent equation techniques. Simply by the dependent equation techniques. Okay, dear. Simply and simply by the dependent equation technique I have solved this earlier. Okay, next question. This also, the next question I solved by the contradiction method. First I solved by the contradiction, then the official rank method. Okay. Next question, please answer. Next question, please answer. Gate 25, computer science, MSQ 1 mark question. MSQ it is. Okay. What is there? Let me convert this into the equation. What is going to happen? The first equation will be, okay, kx plus y is 1. Second equation will be x plus ky equal to minus 1. Okay, and the question is asking no solution, infinite solution, unique solution. Okay, what is the condition for unique solution? I told you easily, if A is a square matrix, A here will be a 2 cross 2 square matrix. Okay, A will be a 2 cross 2 square matrix. So unique solution means only determinant method. Unique solution means determinant not equal to 0. What will be determinant of A matrix? Determinant of A matrix, it is going to be k square minus 1. This should be not equal to 0. That means k square not equal to 1, k not equal to under root of 1 plus minus 1. That means system of equation will have unique solution for k not equal to plus minus 1. Okay, that means the system of equation has unique solution for infinite values of k. Yes or no? Tell me. The system will have unique solution for k not equal to plus or minus 1. That means any value other than plus or minus 1, and any value can be infinite value. Okay, k not equal to plus minus 1, that means k can be plus minus 2, plus minus 3, plus minus 100, plus minus 1000, and even non-integer also, anything. They just told k is real. Okay, so like this, k can take how many values? Like this, k can take infinite values. Only it cannot take 2 values. Okay, so yes, the system of equation will have unique solution for infinite possible values of k. D is correct. Okay, now if k is plus or minus 1, then only it will not have unique solution. Okay, so what is the condition happening at k equal to 1? If I choose k equal to 1, what will happen? See, k equal to 1, put down in the equation. First equation, x plus y equal to 1. Second equation becomes x plus y. Listen here, k is 1, so this is also x plus y minus 1. What happens now? Please tell me what happens now. And if k equal to minus 1, then what happens? If k is minus 1, the first equation will be minus x plus y. I'm just substituting and showing to you. Okay, minus x plus y equal to 1. And second equation will be x minus y equal to minus 1. Tell me what happened now. Tell me what happened now. See, x plus y is 1, same x plus y is minus 1. That means fight, clash. First and second don't agree to each other. They contradict. What is x plus y? I say 1, you say minus 1. Fight, clash, contradiction. Okay, this is contradiction. And contradiction is related to what? No solution. This is contradiction, meaning no solution. Okay, so the system of equation will have no solution for only one value of k. Yes, for the k equal to 1. Okay, I don't say, right? Let me also figure out whether here also no solution. No, let's figure out here. Okay, let's figure out here. What is happening here? Minus x plus y is 1, dear. Automatically, if you apply minus from your side, it becomes x minus y equal to minus 1. That means here, equation number 2 is just negative of equation number 1, dependent. That means equation 2 is a redundant information, not required. It is automatically derived from first. Okay, useless. So that is what dependency is. Okay, so here you have dependency, and dependency in equation is related with infinite solutions. Okay, so yeah, no solution for only one possible value of k. Okay, that is k equal to 1. That is k equal to 1. Infinite solution also for exactly one value of k, that is k minus 1. Infinite solution for infinite values of k, no, this is wrong. C is wrong, ABD. Okay, it has no solution for exactly one value of k. What is that one value of k? What is that one value of k? K equal to 1. It has infinite solution for exactly one value of k. What is that one value of k? Minus 1. Correct answer ABD. MSQ question, 3 answers are correct. Analysis question, a basic analysis question. Gate 25 CS 1 mark question. So many times you can see even 2 cross 2 basic question can also be there, but you should also always know all the 3 conditions: unique solution, infinite solution, and no solution. Correct na? Next question. Okay. Now, when the right side becomes 0, 0. Now, let me first write it in our regular equation format here. Okay. So, again, a MSQ question, mechanical 2 marks. See what's happening here. See what is going to happen here. Please see. Okay. 2x plus alpha y. 2x plus alpha y. See, when you multiply first column, what is the first equation you will get? 2x, okay, plus alpha y. Okay, equal to what is here? 0. Then when you multiply this first row with second column, you get x into 5 minus 2 alpha, or 5 minus 2 alpha times x, okay, plus y is again 0. Okay, when the right sides, all the constants are 0, the equation is also known as homogeneous set of equations. Homogeneous set of linear equation, okay, which will have trivial or non-trivial solution. Okay, now see here in homogeneous equations, the no solution case is ruled out. There will not be no solution case here. Why? Because for whatever value of the coefficient, whatever alpha, beta, whatever coefficients are given, 0, 0 is always satisfied. You see here, if x and y are 0, 0, 0 plus 0 will be 0. 0 plus 0 will be 0. Not only here, let me go to a general discussion first. That is what? If B right side is a null matrix, normally system of equation was AX equal to B. But when the right side is null, everything 0, then the system of equation becomes homogeneous system of equation. Okay, and here 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is again 0. That means all the 3 equations are satisfied. So 0, 0, 0 is always a solution. Okay, 0, 0, 0, x, y, z, 0, 0, 0 is always a solution. That is why I am telling solution case will not come up here, because independent of the matrix A, there is no B here, B becomes 0, but independent of matrix A, independent of rank, anything, always one solution will be there. So that means now you have to figure out 2 things. whether there is only one solution or whether there is more than one solution. More than one means infinite. Okay, more than one. So that's what, yes, 0, 0, 0, already I've told you, is always a solution. That's the thing I told you. Okay, but when 0, 0, 0 is the only possible solution, then the system is said to have trivial solution. Trivial is something which is almost, like meaningless, which does not give you any add-on information. Why? Because if xyz is 0, 0, 0 means in the vector form x is 0. So dear, you are solving the equation ax equal to 0 and a into 0 is always 0. What is the new discovery in that? A into 0 always 0, na? Okay, so it's like almost a meaningless talk. Everybody knows it. Okay, but is there any non-zero value of xyz, okay, which will satisfy the system of equation? Then the system is said to have non-trivial solution. Okay, that means when there is only one solution, unique solution, trivial solution. Okay, 0 anyways will be there, but if you have more than one solution, some non-zero solutions also, then non-trivial solution. Okay, so condition is finally here. Okay, what you know is trivial solution is related to unique solution, and unique solution means, I told you, rank of A equal to n. Okay, and if A is a square matrix, okay, if A is a square matrix, then you can check the determinant also. Infinite solution is related to non-trivial, and what is the condition for infinite? Rank of A will be less than n. There is no A is to B matrix here because there is no B here. Okay, rank of A will be less than n, or determinant will be 0. Okay, if A is a square matrix again, if A is a square matrix. Okay, and if the system of equation has infinite solution, one more point not to be derived here, but just note down, if a system of equation has infinite, many solutions, there will be only n minus r independent solution, rest will be dependent. Okay, there will be n minus r. What is n? The number of variables. Okay, and r is the rank of A. See, n is the number of variables and also equal to, this point I already told you, number of variables is equal to number of columns. Okay, and minus r means the rank of the given matrix. Okay, the rank of this given matrix in the system of equation. Okay, now as I am telling you, there will be n minus r independent solutions. Okay, which satisfy ax equal to null, ax equal to 0. All these independent solutions, okay, all these independent solutions x, which converts the matrix into null, which satisfies ax equal to null, are said to constitute null space of the matrix. Okay, said to constitute null space of the matrix. What is the meaning of null space? The set of all non-zero independent vectors, okay, which converts the matrix A into null, converts the matrix A into null. Or you can say simply like this, or which satisfies, simple language, which satisfies ax equal to null, ax equal to 0. Okay, those non-zero independent vectors x which satisfy ax equal to 0 are said to form the null space of the matrix. Okay, and the dimension, okay, the dimension of null space is the nullity. Dimension means how many vectors. So how many such independent vectors are there? Just now I told you this formula, n minus r. Okay, these number of independent vectors are so said to be the dimension of null space, also known as nullity. Okay, what is the nullity formula then? N minus r. And again I told you number of columns or number of variables I have written here also, and r means the rank of the matrix. R is the rank of the matrix. R is the rank of the matrix. A may be non-square or square, anything. Non-square or square, anything. Square also means what? N cross n. Then also number of columns is number of variables. Okay, the nullity is given by n minus r. Okay. Now let's go back to the question and understand. Yeah. Achha, see, I just took this question. Let me complete this. Sometimes it can be direct question which does not require the knowledge of trivial, non-trivial, nullity, null space. It's a direct logical equation based question. 1 mark only. Okay, then I will go back to the previous question. See what is there in this question. Choose the solution set corresponding to the system of 2 equations. Okay. And only 2 equations are given, 3 variables, but only 2 equations. See here, what is happening from the third equation? Okay, you can say that z equal to x. X minus z is 0, the z equal to x. Substituting this in the first equation. Okay, what I have substituted? I will substitute z equal to x. The equation becomes x minus 2y plus x equal to 0, which means 2x minus 2y 0. 2 you can cancel, which again means x minus y equal to 0, which also means y equal to x. That means if I choose, okay, if I choose x equal to some number alpha, okay, y will also be x, that is alpha, and z will also be x, that is alpha. Okay. If I assume x, x can be anything. Now, what you can assume for x? Infinite possibilities. But then what will happen? Y and z, both of them will be alpha. So what is the solution vector? Okay. What is the solution vector? You can write it as alpha, alpha, alpha. Or you can take alpha common and write it as 1, 1, 1. Okay. So what can be the solution set? It contains what type of vectors? Alpha 1, 1, 1, where alpha can be any real value. Option number A. Alpha can be any real value. Tell me any doubt in this. Tell me if there is any doubt here. Okay. Yeah. Otherwise, let's go to the next one. Yeah. So going back to the previous question that I've shown you. Yeah. So these are the two equations. Right side zeros means homogeneous equation. Okay. Now this linear system of equation involves a real parameter alpha and has infinitely many non-trivial solution. Okay, what is the condition for non-trivial solution? I just told. Non-trivial solution, A is a square matrix, 2 cross 2 matrix. Okay, determinant of A should be 0. Non-trivial solution means, infinite solution means determinant equal to 0. Okay, for some special value of alpha. Which one or more among the following option is or are non-trivial solution for such special values of alpha? But can we first find, okay, the value of alpha? Okay, for what value of alpha non-trivial solution will be there? Determinant A equal to 0. Okay, so determinant of A equal to 0, that means determinant of A means, let me put down this number. A according to our equation arrangement is 2 and alpha, and 5 minus 2 alpha and 1. This is equal to 0. This is equal to 0. Okay, solving this you will get 2 minus alpha 5 alpha minus plus 2 alpha square is 0. So basically a quadratic equation is there. 2 alpha square minus 5 alpha plus 2 equal to 0. Solving which I should get minus b, that is 5 plus minus root over b square minus 4 ac, that becomes 16 divided by 2a. So this is 5 plus minus under root 9, that is 3. 5 plus minus 3 by 4. So 5 plus 3, 8. 8 by 4 is 2, and 5 minus 3, 2. 2 by 4 is 1 by 2. Okay, so there are two such special values of alpha. Okay, firstly, what is the condition? There is no role of beta. That's what, na? If x is known, y and z are directly x. It is not any other combination. That is just randomly written in the option beta. Surendra, just to create the options. Okay. So this is what is given to me. Okay, the first thing is system of equation will have non-trivial solution for alpha equal to 2 or 1 by 2. These are the two special values of alpha. The question says it has non-trivial solution only for some special values of alpha. These are the special values of alpha. These are the special values of alpha. Now, for alpha equal to 2, how the equation will look like? Suppose if I take alpha equal to 2, what is the first equation then? Alpha is 2 means 2x plus 2y equal to 0. Okay. Equation number 2, 5 minus 2 alpha will become 1 if alpha is 2. Yeah. So second equation is x plus y equal to 0. Now you see, if x plus y is 0, 2x plus 2y is automatically 0. Na? Okay. You multiply this into 2. Okay. Dependent equation. That is why infinite solution. Okay, that means only one equation you have. Only one equation. What is the moral from this? Only one equation, x plus y equal to 0. Okay, only x plus y equal to 0. So what are the values of x so that x plus y equal to 0? There can be many possibilities. Okay, so that x plus y is 0. Okay, so option number A is correct. This will be a solution for alpha equal to 2 minus 2 plus 2, but not this, not this, not this. Okay, the option number A will satisfy for the first condition. Option number A will be satisfied here. Okay, now if I take alpha equal to 1 by 2, okay, then what is the first equation? Equation is 2x plus alpha y. 2x plus half y is 0. Equation number 2. 5 minus 2 alpha, 2 alpha becoming 1 here, 5 minus 1, 4. So this is 4x plus y equal to 0. Again, dependent equation. Why? Because you see, if you multiply first equation into 2, you will get 4x plus y equal to 0. Okay, so basically let me take only one equation, and that one equation is 4x plus y equal to 0. 4x plus y equal to 0. Now see, 4 into minus 1 plus 4 will be 0, correct? So B will be satisfied here. Okay, so B is also a solution for alpha equal to half. Then 4x plus y, 4 into 1 plus 1 will not be 0. 4x, 4 into 4, 16, and then minus 2. This will not be 0. 4x plus y should be 0, or y should be minus 4x. That is satisfied by option B. So there are two possible options for this question, A and B. There are two possible answers for this question, and that is the A and B. Tell me any doubt here. Okay, yes, shadow, correct. Okay, one of the solution is for one value of alpha, another solution is for another value of alpha. Okay, let's go to the next question then. This was some quick review that I have taken. This question anyways we solved. Yeah, gate 21 CSE 1 mark. Okay, just language you have to understand and answer the question. Just language you have to understand and answer the question. What is there in this question? Suppose that P is a 4 cross 5 matrix such that every solution of the equation Px equal to 0 is a scalar multiple of 2, 3, 4, 5, 1 transpose. Every solution of Px equal to 0. Okay, Px equal to 0, homogeneous system of equation. Px equal to 0 means homogeneous system of equation, and every solution of it is a scalar multiple of this. That means all solution. Okay, that means scalar multiple, or I'll say like this, all solutions are like this, some scalar multiple. Okay, let's say this is some vector x. Okay, so all solutions are the scalar multiples of this, that is kx. All solutions are in the form of kx. That means all of the solutions are dependent on x. Okay, so how many independent solution? Only one independent solution. Okay, so it's a homogeneous system of equation with non-trivial solution. Why non-trivial solution? Because there is a non-zero vector. Okay, there is a non-zero solution means non-trivial solution. Okay, but only one independent solution. Okay, how many independent solution? The independent solution is given by the formula n minus rank of A or rank of P. The name of the matrix is P here. The number of independent solutions I told you, the nullity given by the formula n minus rank of the matrix, and this is 1. N is what? Number of columns or number of variables, which will be 5. 5 minus rank of P will be 1. So what is the rank of the P? That is the question. So 5 minus 1, 4. Okay, 4. Correct answer 4. No, rank is not 1. Rank is 4. Chinmay, correct answer. Okay, one independent solution and number of independent solution is given by n minus r. N minus rank of the matrix. Okay, so the rank will be 4. Okay. Chinmay, earlier you gave correct. Not rank is 1. Tell me how. Okay, everybody just correct your answers and let me know if still there is any confusion, because every solution is a scalar multiple of this. Every solution is a scalar multiple of this. That means every solution is dependent on only one vector x. So only one independent solution, and number of independent solution is given by the formula n minus r. N has to be taken as 5, number of columns. Okay now? Shadow, any more confusion or all okay? Right, the rank has to be 4. The correct answer, rank will be 4 here. Next question. Now see here, gate 23 civil 2 marks question. Two vectors 2103 transpose 1012 transpose, they belong to the null space of a 4 cross 4 matrix of rank 2. Which of the following vectors also belong to the null space? Now listen, Okay, there is a 4 cross 4 matrix. So what is the n? Number of columns is 4. The rank of the matrix is 2. And in such case, how many independent solutions will be there? Okay, in such case, okay, they talk about null space. What will be the dimension of the null space? Okay, the dimension, or also known as nullity, is given by the formula n minus rank of the matrix. Okay, n minus rank of the matrix. N is 4, rank is 2. So 4 minus 2 will be 2. Now, when I say dimension is 2, when I say dimension is 2, okay, when I say dimension is 2, I also mean that, listen to me, okay, I also mean that there will be, what is the meaning of dimension of null space? How many independent, okay, solutions, okay, how many independent vectors? So only 2 independent vectors. Okay, only 2 independent vectors, rest all dependent. Now see here, given 2 vectors, listen to the next logic now. Given 2 vectors, 2103 and 1012. Okay, let me write it here. X1 in the transpose form, 2103 and X2 is 1012. First of all, are they dependent or independent? Listen to this question carefully. Are these two alone dependent or independent? Are these two alone dependent or independent? What I think is, I will complete the today's session, but then you don't ask a one-shot mathematics session because I see the attendance. Okay, if this is what is the attendance, I thought I'll bring a probability such session also, but I don't think I should bring it now anymore. Okay, because students, they just demand, but their sincerity level, dedication level is all zero. Or they have done it already, PYQs. That's a good scenario. Okay. Surinder, then you can only say the maximum rank is 4. Then you still can't say rank 4. 4 cross 5, maximum rank 4. Okay, but whether the rank is 4, 3, 2, that you have to conclude by the formula n minus r. Okay. So now x1, x2, are they dependent? If they were dependent, x2 should be some multiple of x1, but 1 cannot be converted to 0. 1 into anything cannot be 0. Okay, so no, these x1 and x2 are alone independent. So I tell you that there are only 2 independent vectors in the null space, and those 2 independent vectors are already given. Those 2 independent vectors are already given. That means rest are all dependent. Okay, rest are all dependent. Which of the vectors are dependent on x1 and x2? There can be any dependency on x1 and x2. ax1 plus minus bx2. ax1 plus minus bx2. Okay, any type of dependency. What is the meaning of any type of dependency? It may be x1 plus x2. If I take ab1, it may be x1 minus x2. It may be 2x1 plus 6x2, or any such combination can be formed. Any type of dependency you can create. Okay, so at least, okay, if I start with x1 plus x2, when you add 2 plus 1, 3. 1 plus 0 should be 1. 0 plus 1 is 1. 3 plus 2 is 5. Okay, any option like this? No. 2 plus 1, 3, 1 plus 0, 1, 0 plus 1, 1, 3 plus 2, 5. No, this is not matching. If I start with subtraction, okay, okay, 2 minus 1, 1, 1 minus 0, 1, 0 minus 1, minus 1, 3 minus 2, 1. Yes, so this option given is nothing but x1 minus x2, and this is a MCQ question only, not MSQ. So only one option you scan, enough. Okay, so this one option x1 minus x2 is the correct answer, because any other vector has to be dependent on x1, x2. There cannot be third independent vector. Why? Because I'm telling you only 2 independent vectors. Why only 2 independent vectors? Because the number of independent vectors or solutions are given by n minus r. I calculated that. So there will be only 2 independent solutions. Out of them, the given 2 vectors are already independent. I tallied that. Okay, so there cannot be a third independent vector. Any other third vector in the null space has to be dependent on x1 and x2. And what is dependency? Okay, it may be x1 plus x2, x1 minus x2, 2x1, 6x2, any sort of dependency can be there. So option number A satisfies x1 minus x2. And because it is MCQ question, I will not check any other option. That's it. Option number A. All right. Okay. Option number A. Next question. Okay, gate 22 ME mechanical MSQ 2 marks question. Okay, A is a 3 cross 5 real matrix of rank 2. Okay, for the set of homogeneous equation Ax equal to 0, where 0 is a 0 vector and x is a vector of unknown variable, which of the following is or are true? Is or are true? Now see, the given set of equations will have a unique solution. Okay, is it possible that the system of equation, now see again what is given? Homogeneous set of equation. Okay, homogeneous set of equation Ax equal to 0, where A is a 3 cross 5 matrix. If A is 3 cross 5 means number of variable is 5, so x will become 5 cross 1. X will be 5 cross 1, A is 3 cross 5. Then only matrix multiplication will follow. Na? The number of columns of first should be number of rows of the next. Okay, so x is a column vector. How many entries? 5. Okay, now the rank of the matrix is 2. Okay, what is given? That the rank of the matrix is 2. Okay, which is less than the number of variables, because the number of variables is 5. Okay, the rank of the variable is less than n. The number of variables is 5. Okay, so system of equation cannot have unique solution. It will have non-trivial or infinite solution, because in a homogeneous equation world, we also call it as non-trivial condition, non-trivial or infinite solutions. Okay, so this is the first thing. It cannot have unique solution. For unique solution, rank should be n. So it will have infinitely many solutions. The C is correct. A is wrong. Okay, the given set of equations will have many but finite. This I already told you, no. Either one or more than one means infinite, not like 5 or 10 or 50 solution. It will have a finite but many but finite number of solution. No, many means infinite only. So D option ruled out. A wrong. Okay, the given set of equation will be satisfied by a 0 vector of appropriate size. Now Ax equal to 0, homogeneous system of equation, x equal to 0 is always a solution, whether trivial or non-trivial, whatever it is. Na? If x equal to 0 is always a solution. So it will be satisfied by a 0 vector. Yes, it will always be satisfied by a 0 vector of appropriate size. What appropriate size? That also I will tell you. That appropriate size is 5 cross 1. Okay, because that vector x will be 5 cross 1 in size. Okay, so yeah, they are not asking the size, but will it be satisfied by a 0 vector? Yes, blindly, independent of rank, because x equal to 0 is always a solution of homogeneous system of equation. Always a solution of homogeneous system of equation, correct? This one is always a solution of the homogeneous system of equation, correct na? Then simple, B and C. Simple means good question in terms of concept, 2 marks. Okay, but not in terms of solution. It is not lengthy. You should know the basic points. You should connect the dots. Got the answer. B and C. Any doubts, please mention here. Any doubts, please mention here. All right, now eigenvalue and eigenvector based question. If the sum and product of eigenvalues of a 2 cross 2 real matrix are 4 and minus 1 respectively, then very simple question for 2 marks. Okay, but yeah, this is what forms many a times the most important, the very frequent question on eigenvalues, only based on sum and product. Okay, the sum and product. Okay, what is the sum of eigenvalues? Sum of eigenvalues, sum of lambdas is always equal to the trace. Okay, and that is given as 4. The next property that you should always know, product of lambdas equal to det of the matrix. Now see, the sum of the eigenvalue is given as 4. Okay, what should be the sum of eigenvalues? That is 4, and that should be equal to trace. What is a trace? Trace means sum of diagonal elements. Okay, that is 3 plus q. Okay, that is 3 plus q. So from here directly you get the value of q equal to 1. Okay, and next, product of eigenvalues, that is product of lambdas equal to determinant. Okay, so product of eigenvalues given as minus 1, and that is equal to determinant, that is 3q minus p square. Q is already 1. Okay, so it becomes 3 minus p square, from which you get p square as 4. So what is the value of p? Plus or minus 2. The value of p will be plus or minus 2. Okay, so what is the determinant of p? Actually, they are asking to convert to NAT. That is why they asked the one value, the absolute value, determinant value will be 2. Okay, finish. 2 mark question. Yes, yes, yes. Tirumala, correct answer. Shadow, correct answer. Answer is 2. The answer for the question is 2. The answer is 2 here. So these are some of the important properties of the eigenvalues and eigenvectors. Okay, see, sometimes you may also require to solve the eigenvalues and eigenvectors. So that also I'll tell you if required, because whenever we talk about eigenvalues, na, okay, if you have to talk about eigenvalues, quick revision. Okay, you just solve the characteristic equation. What is the characteristic equation? Determinant of a minus lambda I equal to 0. Determinant of a minus lambda equal to 0. I will give you the simplified characteristic equation for 2 cross 2 or 3 cross 3. Whenever there is a question on eigenvectors, okay, you normally satisfy, okay, see, the conventional method is eigenvectors. Eigenvectors are the solutions of the equation ax equal to lambda x, because if x is an eigenvector, a into x is proportional to x, multiple of x, or we write it this way also, a minus lambda I into x, taking everything common on the left side, which becomes a homogeneous system of equation. So eigenvectors are the solution of this homogeneous system of equation. Okay, or for MCQ or MSQ, for your gate level question, whether it is MCQ or MSQ, I will show you in every type of question this approach satisfy. You just have to take this approach, satisfy ax equal to lambda x. That's it. You will just have to satisfy ax equal to lambda x. You will get what is the required by the question. So every type of question will come. Okay. Now when you talk about characteristic equation, okay, for a 2 cross 2 matrix, suppose, okay, suppose A is a 2 cross 2 matrix. Okay, something like this. A11, 12, 21, 22. Okay, the characteristic equation, okay, rather than using the modulus a minus lambda equal to 0, you can directly use lambda square. Okay, because this is very common that you may require the characteristic equation of 2 cross 2 or 3 cross 3 separately. Okay, lambda square minus trace into lambda plus determinant of the matrix equal to 0. If you use this, you save a lot of time. Okay, so always remember this characteristic equation for 2 cross 2. As and when required, we will use it. Okay, for 3 cross 3. Beyond that, I will not give you any formula. Beyond that means general characteristic equation. This also is coming up by solving mod of a minus lambda equal to 0. Okay, similarly for 3 cross 3 matrix, suppose like this, matrix A11, A12, A13, A21, A22 and A23, A31, 32, 33. Okay, so you know what is the characteristic equation? Solving the same equation, modulus a minus lambda, what do we get? We get lambda cube minus beta 1 lambda square plus beta 2 lambda minus beta 3 equal to 0. Okay, equal to 0. Right. So on solving this, what do I get? Lambda cube. Okay, now, oh, sorry. I'll tell you first what is beta 1, beta 2, beta 3. I've written it in the form of beta 1, beta 2, beta 3. Beta 1 is again the first factor which will be the trace of the matrix A, sum of diagonal elements. Okay, beta 2. Now, what is beta 1 is the sum of diagonal elements. Beta 2 is known as sum of minors of diagonal elements. Okay, any matrix given on the runtime you can calculate. Okay, suppose this is the first diagonal element. Delete the first row, first column, the leftover minor. Okay, that is 2, 2, 3, 3 minus 3, 2, 3, 3. That value is the first. Then sum of all such minors. Minors of what? Only diagonal element. Next and next. So 3 minors you will be required to calculate. Next, what is beta 3? Beta 3 will be the determinant of the matrix. Okay, the last factor will again be the determinant. Okay, so these two common cases you should remember. And I'll tell you many of the questions actually will be property based. And the commonly used properties are sum and product. Number one thing, the commonly used properties are sum and product of eigenvalues. Okay, sum and product of the eigenvalues, right? Any confusion up to here? Any confusion in these factors? Please let me know. Okay, please let me know if there is any confusion here up to this point. Yeah, cool. All okay up to this point? Yeah. So moving forward now. Okay, so this was the first question that you have taken directly on the sum and product of the eigenvalues, and these are the properties that I will highlight. Okay, first two being very important. Sum of eigenvalues is trace, product of eigenvalues is the determinant. Okay, very important, very useful. For the third one also, commonly used property in the questions. Okay, for a real matrix, if there is a complex eigenvalue, it will be in the conjugate pair. Okay, that means if alpha plus I beta is an eigenvalue, alpha minus I beta will also be an eigenvalue. Okay. The total number of linearly independent eigenvectors of a matrix are equal to the number of distinct eigenvalues of the matrix. Okay, I'm just reviewing the property, then in the flow we'll solve the question. As and when required, we'll use the property. For any triangular matrix, upper or lower anything, okay, upper or lower anything, okay, the eigenvalues you don't calculate, you directly write down the diagonal numbers. Yes, eigenvalues are just equal to these diagonal numbers, a11, a22, a33. That is the answer. You don't have to calculate additionally if it is a triangular matrix. Okay, upper or lower triangular, or in fact, or if it is a diagonal matrix also. If it is directly a diagonal matrix. Okay, so whatever in all these three cases, the eigenvalues will be just equal to the diagonal numbers. Next one. Now, next one. Okay, see, even this upper triangular one is important, but next one I will say one of the very important property repeatedly asked in the exams, directly, indirectly useful in the question. What does it say? If a matrix has eigenvalue lambda and eigenvector x, the matrix A power n will have the eigenvalue lambda power n with the same eigenvector. The matrix A inverse will have the eigenvalue lambda inverse, that is 1 by lambda, okay, with the same eigenvector. The matrix A plus I will have the eigenvalue lambda plus 1, same eigenvector. The matrix K into A, eigenvalue K into lambda, same vector. That means any operation you apply on A, f of A, any operation you take on A, okay, the eigenvalue, same operation to be done, f of lambda, a power n, like a square, lambda square, a cube, lambda cube, a inverse, lambda inverse, a plus I, lambda plus 1. Whatever operation you do to the matrix, same operation is applied to eigenvalue, but eigenvector is same. Okay, now A transpose, this is not a function of A. A transpose is a separate matrix where you exchange the rows and columns, but if the matrix is A transpose, eigenvalues remain to be same, lambda, but eigenvectors, okay, no property, you have to find separately. We don't say eigenvector as same here. Okay, but any operation you do as far as only on a square, a cube, anything of that kind, okay, the eigenvalue will satisfy the same thing with the same eigenvector. We will see multiple questions on this property directly or indirectly. Number 7. If sum of the elements of every row is same, then one of the eigenvalue equal to that sum. Okay, the rank of a matrix is number of there is a connection between rank. The rank of a matrix is number of non-zero eigenvalues of the matrix. Okay, this is applicable except diagonal or triangular matrices. Only one exception to this property. Otherwise, this is a helpful property. Rank equal to number of non-zero eigenvalues. The eigenvalues. Now, some questions, some properties for statement can be important. Eigenvalues of a real symmetric matrix are always real. Now, this is again an important property. The eigenvectors corresponding to distinct eigenvalues of a real symmetric matrix are orthogonal to each other. The eigenvectors corresponding to distinct eigenvalues of a real symmetric matrix are orthogonal to each other. That means corresponding to distinct eigenvalues. That means if there are two distinct eigenvalues, lambda 1 not equal to lambda 2, okay, for a real symmetric matrix, the eigenvectors of these two eigenvalues will be orthogonal to each other. Okay, that means suppose the eigenvector is x1 and this eigenvector is x2. They are orthogonal or perpendicular. That means their dot product x1 transpose x2 equal to 0. Okay, the dot product x1 transpose x2 equal to 0. Okay, eigenvalues of a real skew symmetric matrix are either 0 or pure imaginary. Eigenvalues of a Hermitian matrix are always real. Eigenvalues of a skew Hermitian matrix are again either 0 or pure imaginary. Eigenvalues of a unitary matrix or a real orthogonal matrix. Okay, what is this orthogonal matrix? Real orthogonal matrix which satisfies A transpose equal to identity. What is a unitary matrix? Okay, complex unitary matrix which satisfies AQ equal to I. What is AQ? AQ is equal to A, conjugate transpose. The AQ matrix is known as the conjugate transpose matrix. Okay, some basic terms. Okay, you already know what is a symmetric matrix, A transpose equal to A. You already know what is a skew symmetric matrix. A transpose is negative of A. What is a Hermitian matrix? Okay, it's a complex conjugate symmetric matrix. AQ equal to A. Okay, skew Hermitian matrix, AQ equal to minus A. These are the basic definition of matrices, you know. Okay, but what are the eigenvalues? Directly in the statement form. Okay, or sometimes they can make a MSQ question combining these properties. So that is why I have shown you these properties also. Now the next question. Okay, gate 21 double even mark. P and Q are real numbers such that P square plus Q square equal to 1. What is the eigenvalues of the matrix P, Q, Q minus P? Eigenvalues of this matrix P, Q, Q and minus P. So simple, na? Okay, the eigenvalues, okay, if I just take the sum, okay, what should be eigenvalues? The sum of them is equal to trace. Sum of eigenvalue 0. Now, sum of eigenvalue 0 is possible in option A, B, C. Only D is discarded. But product of eigenvalue, just using the sum and product. What is the product of eigenvalue? Equal to determinant. Now, what is going to be the determinant here? Minus P square minus Q square. Minus, if you take outside, P square plus Q square is anyways given as 1. Okay, the product is minus 1. Okay, product is minus 1. Okay, and sum is equal to 0. Now, product equal to minus 1, na? See, the product of this is minus P square, Q square, not allowed. Product here will be 1. Product here is minus 1 because here the product will be minus J square, which is plus 1. So, product equal to minus 1, only option number C. Finish. Product of eigenvalue equal to minus 1 is only option number C. Is only option number C. Yes, correct answer, Shadow and Tirumala. Only option number C. Only the option number C. Okay, next question. Okay, gate 21 EC 2 marks. A real 2 cross 2 non-singular matrix A with repeated eigenvalue is given as A equal to x minus 3, 3 and 4, where x is a real positive number. What is the value of x? What is the value of x? Come on. Okay, a real 2 cross 2 non-singular matrix. Non-singular matrix you anyways know. Non-zero determinant, the determinant will be non-zero. Okay, with repeated eigenvalue, okay, repeated eigenvalue. So suppose there is 2 eigenvalue and both of them are lambda and lambda. There is no lambda 1, lambda 2, both of them are same, repeated, lambda and lambda is given as. So, okay, again if I start with the, sum of eigenvalue, okay, lambda plus lambda equal to trace, that is x plus 4. Okay, so one result from here is, okay, or otherwise, what is the second one? Lambda into lambda. Product of eigenvalue is determinant, and determinant will be 4 into x minus 9 plus 9. Okay, so from here, I want x now, I have to eliminate lambda. So what is this equation? Lambda square is 4x plus 9. Okay, but from the first equation, what can be lambda? This is 2 lambda is x plus 4. So lambda is x plus 4 divided by 2. Okay, so replace lambda as x plus 4 divided by 2. This is whole square equal to 4x plus 9. Let me keep solving. Okay, so x square plus 4 square, 16 plus 2ab, 8x divided by, or I'll send the 4 on the right side. So 2 square is 4 into 4x. Okay, start by this only, equal to 4x plus 9. Okay, now I will send the 4 on the right side. So I will have the equation x square plus 16 plus 8x equal to 4. This is 16x plus 4, 9, 36. Rearrange all the terms on the left side. 8 minus 16 minus 8x, 16 minus 36 minus 20 equal to 0. X square minus 8x minus 20 equal to 0. X square minus 8x minus 20 equal to 0. Right? Okay, so now, how I can factorize? Easy factorization. Okay, I can write this as x minus of 10, x plus 2. X minus 10, x plus 2 equal to 0. So, x can be written as minus 2 and plus 10. X can be written as minus 2 and plus 10. Okay, but here x is a real positive number. Okay, so x is a real positive number given. So, answer has to be x equal to 10. Answer has to be x equal to 10. Right. Answer has to be x equal to 10. Yes, Tirumala, correct. Ritvik, correct. 10 is the correct answer. 10. Yes, Shadow, correct answer. 10. Next question. A matrix has eigenvalues -5 and 7. What are the eigenvectors? What are the eigenvectors? So I told you, whenever it is, see, it's a MSQ question. I think it's not mentioned here. I'll write down here. This is a MSQ only. Whether MCQ, MSQ or NAT, but question on eigenvector. Okay, question on eigenvector. What is the approach? I already told you. What is the approach? I already told you. Just satisfy AX equal to lambda X. AX, and for that you don't need to find out lambda also. Lambda eigenvalues that you can find for 2 cross 2 but not required actually. Okay, why? I'll just show you the approach here. Suppose if I start with option number A, what is AX? Okay, what is A into X? So A is the given matrix 4, 3, 9, -2. Multiply by X, X of the given option 1, 1. Now you see the result. Okay, first row with this first column 4 plus 3, 7. Then 9 and -2, 7. What you can do now? You can take 7 common now. If you take 7 common, you get 1, 1. What is 1, 1? The X. Okay, that means this option number A, when I took A and multiplied by X, answer is 7X. Answer can be any multiple of X. That's what I'm telling. Now, whichever option satisfies AX equal to lambda X, where lambda is any number, the answer should be multiple of X, multiple of the given vector. 2x, 10x, 100x, anything. I got 7x. So yes, it satisfies. Corresponding eigenvalue lambda 7. I don't want the eigenvalue, but whether it satisfied? Yes, A satisfied. A satisfied. But it is MSQ question. You have to be careful and you have to tally all the options. Just have to tally all the options and give me the correct one. You have to tally all the options and then give me the correct answer. Okay. Just have to tally and give me the correct answer. Complete this quickly. Complete this. Just complete and give me the right answer. Okay. Okay, let's check it out. Okay, let's check it out. AX equal to 7x is what is the option number A is telling. Okay, so some of you are telling A and C, 2 options correct. Okay, let us check it. Okay, so now similarly, because it is MSQ, it is important to scan all the options. I will go to the option number B, A into X. A means the same matrix 4, 3, 9 and -2 multiplied by X. What is the X matrix? The X vector is 3, 4. Now when you do the multiplication, 4, 3 plus 3, 4, 12 plus 12, this is 24, 9, 3, 21, sorry, 27 and -8, 19. Now, is it a multiple of 3, 4? If it was a multiple, so 3 into 8. Okay, if you take it as multiple, so 3 into 8 will give 24, but 4 into 8 will not satisfy. Na? 4 into 8 will not satisfy. So this cannot be written as lambda times 3, 4. This cannot be written because again I repeat, if it was possible, then 3 lambda should be 8. But if lambda is 8, 3 into 24, 3 into 8 is 24. But if lambda was 8, 4 into 8, 32, not matching. Na? Both the elements have to match. Na? Left hand side equal to right hand side. So B cannot be the correct answer. Okay, then C. Okay, then C. Again same approach. What is AX? 4 and 3. Okay, 9 and -2 multiplied by X. What is X here? What is X here? 2 and -6. 2 and -6. So I'll multiply 4 to 8 minus 18 minus 10. Okay. Then 9 to 18, 18 and plus 12. 18 plus 12, 30. Can it be written as a multiple here? If it was a multiple, you have to multiply by -5. Correct? Yes. Okay. It will tally for both the element. Why? Because I can now take actually -5 common. If you take -5 common, 2 left here and -6 will be left here, and that is what was applied vector. So C, as some of you are telling, is the correct only. Ax equal to minus 5x, correct. Okay, with lambda minus 5, this is the correct eigenvector. Okay, last step, I have to satisfy D. I have to just check D. MSQ, I can't neglect any option. Okay, now what is the D vector? Is 2, 8. Okay, this is given as 2, 8. Let us check this. Okay, 4 to 8 plus 3 at 24, total 32. Then this is 9 to 18 minus 16. 18 minus 16 only, no? Correct. This is only 2. Okay, I don't think it is going to match because 2 into 16. Okay, then only you get 32. But if you multiply 8 by 16, it is not at all 2. So no, it cannot be written as lambda into 32 2. Yeah, so this is not the correct answer. A and C, as some of you suggested. Okay, the correct answer, Ritvik, Tirumala, Shadow, Nanendra, A and C. Okay, I'll tick mark here as well. The total correct answer are C as well. A and C. These are the two correct answers for the MSQ question. And I will tell you, recently, many a times from eigenvector, MSQ question, because eigenvectors can be multiple, na? Okay, corresponding to a single eigenvalue also there can be multiple eigenvectors. Okay, so that is why MSQ question. Now see, GATE 2024 EC 2 marks MSQ. The previous one I guess was instrumentation. Okay, this one is EC MSQ 2 mark question, GATE 24. For the matrix 1k 2 1, where k is a positive real number. Okay, which of the following is or are the eigenvectors? Again MSQ question. Just make the question simple. Okay, where k is any positive real number, na? Okay, to make the question simple, let k be 1. You can solve generally by k, but it will be more calculative. Let's say k equal to 1. Okay, then if k is 1, then what is the matrix A you will take? You will simply take the matrix 1, 1, 2, 1. It becomes easy to solve. I'm just giving an option. Okay, now I will go to option number A. Again, every option I have to scale and solve Ax. What is A? 1, 1, 2, 1. Multiplied by x. What will be x? K is 1. So only write down root 2 here. Root 2 and minus 1 and solve this. Okay, if you solve this, what is the first number? Root 2 minus 1. Correct? Yeah. And next will be 2 root 2. This was root 2 and minus 1. Next is 2 root 2 minus 1. Now, is it a multiple of root 2 and minus 1? That you have to carefully scan and see whether you can write it as a multiple of root 2 and minus 1. Whether you can write it as a multiple. Only numbers because of under root will be little bit, tedious. The numbers you have to manipulate carefully. Root 2 and minus 1. So, to bring minus 1, I have to take 1 minus 2 root 2 outside. And if I take it from there, no, into root 2 times. If I multiply this by root 2 minus 2. Okay, we'll check the B option also, just a second. A into x will be how much? 1, 1, 2 and 1. And this is further multiplied by 1 and k is 1 here. So, this is also root 2. Let me check the second number also. This is going to be 1 plus root 2 and this is going to be 2 plus root 2. Yeah, this looks more obvious because here I can take the root 2 common. Okay, how can I write down this one as 1 plus root 2 and the second element directly if I take root 2 common. So, this is also 1 plus root 2. So, here I take 1 plus root 2 outside, more easy, and then I get 1 and root 2, and this is what was applied. What is applied? 1 and root 2. Okay. Lambda can be any number, na? Integer, non-integer, surge, complex, anything can be happening. Okay. So, option number B clearly satisfied. Ax equal to lambda x, correct? With what value of lambda? 1 plus root 2. With value of lambda 1 plus root 2. Okay. So, similarly, I was trying to find the logic. Can, like this is 1 and root 2 times. Here, this is 1 and root 2 times. So, even if I take, okay, if I take root 2 common here, na, from the first element, okay, 1 minus 1 by root 2 will come. Okay. Which will not be 2 root 2 minus 1. No. Okay. No. No. So, anyway, you cannot write this as lambda times, okay, root 2 and minus 1. Because, I'll tell you now why. Because B and D are same. Okay, so maybe they are copied same. I'll check the actual question. Maybe they are in copying, they are same. It might be something else. Okay. Now see, I'll tell you why not A correct, because I already taken root 2 outside now. So if this equation you have to match, lambda should be 1 minus 1 by root 2. But if lambda is 1 minus 1 by root 2, this should be minus lambda. So minus 1 plus 1 by root 2. Minus 1 plus 1 by root 2, which is not 2 root 2. So that is why A option is not correct. That is the thing I wanted to check. A option not correct, B is correct. Now let me go to C also. What is there in the C? AX. What is there in the C? Okay, A matrix is how much again? 1, 1, 2, 1. 1, 1, 2, 1 multiplied by X. What is the X vector? Root 2. Okay. And 1. Root 2 and 1. Okay. Now, yeah, if I multiply, what do I get? Root 2 plus 1, the first element. Next, 2 root 2 plus 1. Okay. 2 root 2 plus 1. Now, again the same thing. If I try to take root 2 common from here, I will get 1 plus 1 by root 2, and the next element is like this, 1 plus 2 root 2. Correct na? Now, can it be written as lambda times the given vector? The given vector is root 2 and 1. Now see, if this is true again, if this is true, okay, lambda has to be how much? 1 plus 1 by root 2. But this element directly should be lambda. 1 plus 1 by root 2 is not 1 plus 2 root 2. Okay, no. So C answer also not correct. C answer also not correct. D answer. Now D answer by chance has come up as same in printing. I guess this should be minus 1. I guess this should be minus 1. Okay, like here minus 1 and plus 1 was the different. Let's make the D answer as minus 1 and then 2 by root over 2 by k. So now I will tally the D answer. A into X. A matrix is 1, 1, 2 and 1. And what is the X vector now? Minus 1 and root 2. K anyways I have assumed 1. Minus 1 and root 2. Okay, so this will become how much? Minus 1 and plus root 2. Next row, minus 2 and plus root 2. Now again from the first, or rather from the second this time, I will try to take root 2 common. So from the second, if I take root 2 common, this will become minus root 2, or let me start from here. This will be 1 and then this will be minus root 2. Correct? So yes, so from the first I will take minus common so that I get 1 minus root 2. Now I will take 1 minus root 2 common, and then I get, this is minus 1, this is root 2, this is what was applied, minus 1 and root 2, this is what was applied. Okay, that means in the D answer also, AX is satisfying some multiple of X, yes, with what value of lambda? 1 minus root 2. What value of lambda? 1 minus root 2, correct. So D answer correct, B answer correct. Okay, 1 and root over 2 by k, minus 1 and root over 2 by k, B and D. Yes, D also correct. Okay, so D, I mean there was a typo error, any one of them would be given as minus, anyways both will satisfy. Okay, X or minus X, both will satisfy. That is what it is, okay. Chalo. Next question. Now you see, this was MSQ, 2024 EC, 2022 instrumentation 2 marks MSQ, 2024 EC 2 marks MSQ. One question, okay, I will leave as homework because this is only calculative, because 4 cross 4 are definitely time taking. Okay, but the same approach, 2022 CS MSQ 2 marks question, but same approach. Again, you have to verify AX equal to lambda X. Approach is the same. You have to just verify AX equal to lambda X and get the correct answer. See, 4 cross 4 usually lengthy calculation, but you see the option, it's not going to be way lengthy also. Why? Because you see the option. Okay, zeros are there in the vectors and that 0 will simplify. Like here there are 2 zeros. So because zeros are there and simple numbers 1, 2, 3, so not a very typical calculation, but little lengthy as compared to the previous cases because of only 4 cross 4 multiplications. Okay, next one. So this I will leave as homework. Whenever you solve, you can drop your answer in the comment box so that others can also drop, and you compete in the comment box as well. Next question for you. Here it is. Consider a n cross n matrix A and a non-zero n cross 1 vector P. Their product AP is alpha square P, where alpha belongs to R and alpha does not belong to minus 1 or 0 or 1. Okay, based on the given information, what are the eigenvalues of A square? Dear, what is this? A simple question, gate 21 mechanical 1 mark question. What is given? AP equal to alpha square P, where P is some vector. Is it not like just the relation AX, where X is some vector, is lambda into X? It is just like AX equal to lambda X, where Okay, P then becomes what? What is that vector P for the matrix? Vector P then is going to become, just a second here. Yes, guys, just complete this. I'll just join in a while. Yeah. Yeah. Okay, students. So what I was telling you, AP equal to alpha square P, where alpha square is eventually some number. Okay, it is like the relation AX equal to lambda X. That means the given vector P is the eigenvector. Okay. Okay, and the answer is proportional to P. Okay, what is that proportionality number? Alpha square, that is the eigenvalue. Now the question is asking, what is the eigenvalue for A square? What is the eigenvalue for A square? Now listen, if A has the eigenvalue lambda, I told you very important property number 6. A square will have the eigenvalue lambda square, but lambda is alpha square, so lambda square becomes alpha power 4. D answer. D answer, not A. D answer is correct. It is directly D answer. Okay. Hi Raghuvardhan. Okay, D answer correct. Next question. Gate 24 instrumentation 1 mark question. What is there? A 3 cross 3 matrix P with all real elements has the eigenvalues 1 by 4, 1 and minus 2. What is the value of determinant P inverse? Got it, Shadow? Na? Okay. That's what. Keep on correcting, keep on learning the thing. So what is there? A matrix P with all real elements has the eigenvalues 1 by 4, 1 and minus 2. What is the determinant of P inverse? P matrix not given, you can't form the P inverse. What is the determinant of P inverse? See dear, very simple logic. Very simple logic. Determinant of P inverse is nothing but 1 upon determinant of P. 1 upon determinant of P. And what is determinant of any matrix? Product of eigenvalues. Determinant of matrix is product of eigenvalues. 3 eigenvalues are given. Okay, so lambda 1, lambda 2, lambda 3. That's it. That is the only thing to be done. So this become 1 upon 1 by 4 into 1 into minus 2. Okay, that too they are asking modulus. Okay, first, no, determinant only. Determinant P inverse only. Correct, yeah. Okay, so this becomes how much? Minus half and going above minus 2. The final answer minus 2. Correct. Final answer minus 2. Minus 2, the determinant of P inverse. Okay. Minus 2, not plus 2, minus 2. Determinant only. Determinant could be positive, negative, anything. So minus 2 is the correct answer. Please check it out once again, Janendra, Shadow and Tirumala. Next question, dear. Given A equal to 2503, the value of the determinant. Now see again, the question looks like a typical question. It looks like complicated, but it is not. Somebody might think, okay, given the matrix A, first I have to form A power 4, A cube, A square, etc. Okay, then only I'll be able to solve this question. No. No. Why? Because I'll simply say that A, what is the type of A matrix? A is clearly an upper triangular matrix, right? A is clearly an upper triangular matrix. So I don't need to calculate eigenvalues. I already know them, because for any upper triangular matrix, eigenvalues are equal to diagonal numbers. Eigenvalues are equal to diagonal numbers, that is 2 and 3. Okay, so that means I know the eigenvalues of which matrix? I know the eigenvalues for A matrix. Okay, so can I also know the eigenvalue for A power 4 minus 5A cube plus 6A square plus 2i. Can I know the eigenvalue of such a given matrix? Okay, I don't need to form this matrix a power 4 minus 5a cube, etc. Can I know the eigenvalues of this matrix? Yes, I can still know the eigenvalue of this matrix. Why? Again, I'll just go back. I told you the important one, na? I told you the important one, na? Again, I just want to go back there. This property is going to be used. What I eventually told, like a has lambda a power n, like in previous question, not the previous question, I used a square, lambda square, a inverse, lambda inverse. Any function of a you take, any operation on a you take, same applies to lambda, f of lambda. Same applies to lambda, it will become f of lambda, correct, na? Right. So that is what you have to do in this question as well. Okay, in this question as well. I'll go back to the question. Here we are. Okay, so what are the eigenvalues for such a matrix? It will become for a power 4 eigenvalue lambda power 4 minus 5 into lambda cube plus 6 into lambda square plus 2 into I means 2 into 1. That's it. So there are the two eigenvalues. So what will be the first one? First one will be 2 power 4. Okay, so 2 power 4 minus 5 into 2 square plus 6 into 2 square, 5 into 2 cube it was, and plus 2. This is net how much? 2 power 4, 16 minus 5 into 8, 2 cube, okay, plus 6 into 2 square, 6 into 4 plus 2. Net answer, let me check here. Okay, 6, 4, 24 plus 16, 40, 40 minus 40 cancel. This is going to be 2. Going to be 2. Second one. Okay, second one. Now, second is 3. 3 power 4. Okay, minus 5 into 3 cube. Okay, 5 into lambda square plus 6. 5 into lambda cube plus 6 into lambda square, that is 3 square plus 2i. That is plus 2 here. Okay, 3 power 4, 81. Minus 3 cube is 27. 27 into 5 should be 135. Plus 6 into 3 square, that becomes 54, and plus 2. Okay, how much should be the net value here? 81 plus 54, 135 plus 2, 137 minus 5. This is again 2. Just a second. 135 cancel. This is also 2. Both the values are coming out to be 2 and 2, I guess, right? Yeah, both are turning out to be 2. Yeah, it's a good question, but you should know the technique. Okay, final answer for both. To just correct me, just tally the calculation once. Okay, what I have got is 2. 2 each. I've got 2 each and looks fine. Right. The other one also looks fine. 2 cube 8, 5, 6, 4, 24, 16 candle. Yeah, 2 each. Correct, na? 2 each. Now, what is the determinant here? Any determinant is equal to product of the eigenvalues. Okay, product of eigenvalues. Okay, so what will I say? Suppose let B be this matrix. Okay, now if B is this matrix, that means determinant of B, determinant of this structure will be product of again eigenvalues. Okay, will be product of lambdas. Product of eigenvalues of B, and that is 2 cross 2. Net answer 4. 2 cross 2, net answer 4. Correct. Okay. One more thing I'll tell you now. Suppose if the question was, just in the same question, suppose if the question was, this is one direct approach, or you may also think about Cayley-Hamilton theorem, but not truly required for this question. Okay, Cayley-Hamilton will be required. Suppose if the question was, okay, what is the matrix? What is this matrix? A power 4 minus 5a cube plus 6a square plus 2i equal to, if I wanted this matrix, that means whenever you need to form a matrix which has higher powers of A, whenever you need to form the matrix which has higher powers of A, understand the two types of question. Higher powers of A, you can use Cayley-Hamilton theorem. Cayley-Hamilton theorem. I will take more questions onto it. Cayley-Hamilton theorem, which simply says that every square matrix satisfies its own characteristic equation. Every square matrix satisfies its own characteristic equation. Okay, so I'll come back here. Okay, what is the matrix A given in the question? the matrix A was 2, 5, 2, 5, 0, 3. This was 2 and 5 and 0 and 3. What is the characteristic equation for 2 cross 2? I told you, na? Characteristic equation for 2 cross 2 is lambda square minus the trace into lambda plus determinant equal to 0. Direct characteristic equation I told you for 2 cross 2. Okay, so when I substitute the value, what will I get? Lambda square minus trace. Trace is 2 plus 3. Okay, plus determinant. Determinant is 2 into 3 minus 0. That is 6 equal to 0. Now, what does Cayley-Hamilton theorem says? Cayley-Hamilton theorem says that every square matrix will satisfy its equation. Okay, that means you can replace the lambda by A. Matrix A, we should satisfy this equation, A square minus 5A. Only thing is, when you are converting to matrix, you can't write 6, you should write 6i. With matrix only, matrix can be added to A square minus 5A plus 6i equal to 0, correct? As per the Cayley-Hamilton theorem, this is the result. But now I need to form what matrix? I need to form the matrix, okay, containing some higher powers of A power 4 minus 5A cube plus 6A square plus 2i. This is what I need to form. Okay, now A square is common from the first three terms. Then what is left? A square minus 5A plus 6i. A square common. Okay, and then plus 2i. Now you see here, what is A square minus 5A plus 6i? As per our recent discussion, Cayley-Hamilton theorem says that this answer will be 0. Okay, so the given matrix is just 2i. So if I ask you to form the matrix, this is the answer. And now what is the determinant? So this is also another approach. What is the determinant? Determinant is 2 cross 2, 4, because it's a diagonal matrix, na? Product of diagonal numbers is the determinant. 2 cross 2, answer here also is 4. That is also another approach. Okay. Right. So this can be like a method 2 also, okay, where you form the matrix, but not truly required. Not truly required. Okay, you can directly, if you only want the determinant of a matrix, determinant is product of eigenvalues, and eigenvalues of this matrix depend on eigenvalues of the given matrix A. That's it. That's the basic thing you can apply here. Okay, that's the basic thing you can apply here. Okay. But if the question is necessarily saying that form the matrix, then you have to apply Cayley-Hamilton. Okay, since I have touched Cayley-Hamilton, okay, I will right now first immediately go to 1 or 2 more questions on Cayley-Hamilton in our recent 5 years. This is the Cayley-Hamilton I made you revise. Okay, here it is. If A is 1, 2, 2 minus 1, which of the following is A power 8? Now see, it's a gate 25 current year 1 mark question CS. Directly the question is asking A power 8. That is a higher power. And whenever the question is asking you to form higher power, it's not that you have to take A and then multiply A with A and you have to just consider multiplication and then come to higher power. No, actually you just have to apply Cayley-Hamilton. Okay, higher power coming up, just apply Cayley-Hamilton theorem. But for Cayley-Hamilton, what you need? Characteristic equation. 2 cross 2 characteristic equation. Again repeating the same point, lambda square minus trace into lambda plus determinant equal to 0. Okay, so what is there? The trace this time, 1 and minus 1, 0. What is the determinant this time? Minus 1, minus 4, minus 5. Okay, so the characteristic equation is simply lambda square minus 5 must be 0. Okay. Now I need to apply what? Now I need to apply Cayley-Hamilton. I will replace lambda by A square minus 5. Don't write 5, write 5i. With matrix, matrix should come. So wherever constant is there, multiply by identity. Okay, so A square minus 5i is 0. What is A square? Is 5i. So the question is finished. What is A power 8? A square whole power 4. That means 5i power 4. 5 power 4 is 625 and I power 4 is I. So answer is 625i. 625i matrix, you know, na? Option number C. I means all diagonal elements 1, 625i. So diagonal elements are 625, 625. Rest is anyway 0, 0. Answer C. Get 25 CS 1 mark question this was. Okay. Another question, gate 22, electrical 2 marks. See, whether they talk about higher powers that or even negative powers. Okay, Cayley-Hamilton, okay, or higher powers of A or even negative powers of A. Now, when I say negative powers of A, so automatically inverse will also come. So, see, what is the next question telling you? Electrical 2 mark question. There is a 3 cross 3 matrix which satisfies the equation 6a inverse equal to a square plus ca plus di, where c and d are scalar number. Okay, what is c plus d? That means first you have to find c and d, and then what is the c plus d value? Okay, the equation is for inverse of a, negative power of a. Then also you can think about Cayley-Hamilton theorem. The question doesn't say that form the inverse of the matrix and then take the square of the matrix and do this arithmetic operation and then compare left hand side, right hand side and then get the value of C and D. No, that is absolutely a waste approach, a time waste approach. No, Cayley-Hamilton theorem should be known. Any power of a, higher powers or negative powers, including inverse. Inverse is again one very common case onto which Cayley-Hamilton questions you can expect. Okay, so let's solve it. What is there? Okay, let us just solve this question. Okay, what is there? The matrix satisfies this equation. Okay, so let me first apply the Cayley-Hamilton theorem. Now, what is the characteristic equation for a 3 cross 3 matrix? Remember, for a 3 cross 3 matrix, I have written it as lambda cube minus beta 1 lambda square plus beta 2 lambda minus beta 3 equal to the 0. Okay, this is what I have written. What is beta 1, beta 2, beta 3? Beta 1 is known as the trace. Okay, this I have told you already earlier. Beta 1 is the trace. Trace here is sum of diagonal elements, which is 6. Okay, now beta 2, listen to me. What is the beta 2 I told you? Beta 2 is known as the sum of the minors of diagonal numbers. Sum of the minors of diagonal numbers. Okay, sum of the minors of diagonal numbers. Okay, so this is the first diagonal number. What about its minor? I'll delete its row and column. What is left? 4 minus minus plus 2. This is the first one. Then second diagonal element, understand here. Second diagonal element is A22. Second row, second column you delete. What is the minor left? 1 minus 0. And then the third diagonal element is here. Delete the third row, third column. What do you get? 4 minus 0. Okay, so this is the net answer. 6 plus 1 plus 4, 11. Okay, this is beta 2. Last step is beta 3. Beta 3 is known as what? Beta 3 is known as the determinant of A. Okay, what about the determinant of A? Simply expanding about first row, only one non-zero element is there, into 4 plus 2. So the determinant is 6 basically. Okay, determinant is 6. Now I will feed this in the characteristic equation. What is the characteristic equation? Lambda cube minus beta 1 lambda square. Beta 1 is 6. Plus beta 2 lambda. Beta 2 is 11. Minus beta 3, beta 3 is also 6. Now I will apply Cayley-Hamilton. Cayley-Hamilton theorem says that every square matrix will satisfy this equation. So satisfy in terms of A, you will get A cube minus 6A square plus 11A minus 6I equal to 0. Because the question is asking an inverse expression, let me multiply both the sides by inverse. To come to a negative power, multiply both the sides by the respective negative power. Now right side A inverse into null will be is null only. Now A inverse into A cube, A square will be left. 1A cancel. Here 1A cancel, 6A will be left. Okay, then plus 11 A inverse into A cancelled identity. Minus 6 A inverse into I will be A inverse. Right side 0. So you can write down the 6A inverse expression on your own by the help of Cayley-Hamilton theorem. And as per these above results, 6A inverse is A square minus 6A plus 11I. A square minus 6A plus 11I. Correct. What is the given expression? 6A inverse is A square plus CA plus DI. A square plus CA plus DI. So C is minus 6. D is 11. So the question C plus D, minus 6 plus 11, 5. Answer is 5. Yes, shadow, correct answer. Okay, 5 is what is the correct answer. Option number A. Again a question on Cayley-Hamilton. 5 is the correct answer. This is again a question on Cayley-Hamilton. Okay. So whenever a matrix given which is formed using higher powers or negative powers of A, including inverse, you can think about Cayley-Hamilton. Okay, or like this question directly A power 8. Okay, going back to our other question, we'll continue with that question again where we were. Yeah, here it is. This is the question. Okay, where we have wanted the determinant of the matrix, we solved directly by the eigenvalue property, or for this question also you could have applied Cayley-Hamilton, but not truly required. Okay, whenever you need to form that matrix, then necessarily Cayley-Hamilton. We only wanted the determinant of the matrix, and determinant is product of eigenvalue. Eigenvalue of this matrix related to the eigenvalue of given matrix. So that simple property was used. Okay, yes, Jnanendra, correct answer. Now going to the next question. See, 1 mark MSQ question, simple one. Why it is simple? The matrix M is defined as 1, 3, 4, 2 and it has the eigenvalues 5 and minus 2. Now see, can't you find the eigenvalues of a 2 cross 2 matrix? Yes, you can. I have already told you characteristic equation of 2 cross 2 directly. You can find on your own, but not required. They have given. They want you what? So that means it is a property based question, not eigenvalue calculation. They have given it. You can calculate, but they have given. The matrix Q is formed as m cube minus 4m square minus 2m. Okay, some function of m. Okay, what are the eigenvalues of Q? So see, matrix M will have some eigenvalue lambda, which is given to you 5 and minus 2. Okay, now what is given? Q is a function of m, some function of m. It will have the eigenvalues f of lambda. That's it. Okay, right. So that means, dear, for the Q matrix, okay, what are the eigenvalues going to be? M cube means lambda cube. Okay, minus 4m square means lambda square, minus 2m means 2 lambda. Simple. Okay, now what is the first eigenvalue? First lambda, okay, is 5 and minus 2. First is 5. So 5 cube minus 4 into 5 square minus 2 into 5. This will be how much? 125. 100. So 25 minus 10. So this is 15. And the second eigenvalue for the same matrix will be same operation applied on minus 2. Minus 2 cube minus 4 into minus 2 square minus 2 into minus 2. This is becoming minus 8, minus 16 plus 4 minus 20 net answer. So the two eigenvalues are 15 and minus 20. Answer is A and C. A direct question on the same property. A and C. A direct question on the same property. Okay. A very direct question on the same property. Next question, dear. Here it is. Direct 2 mark MSQ direct question. For 2 marks, it is direct question. What is given? For the matrix A given, which of the following statement is or are true? Let us see whether we need the matrix or not. The eigenvalues of A transpose are same as eigenvalue of A. I told you this is a general property for any matrix A, not required the matrix. Eigenvalues of A inverse are the reciprocals of eigenvalues of A. Yes, no? Eigenvalues of A inverse are lambda inverse. That is 1 by lambda. Okay. So B answer also correct. Eigenvectors of A transpose, no. I told you A transpose is the only case where eigenvectors, if required, you have to calculate separately. But they are not asking eigenvectors. They are asking eigenvectors of A transpose same as eigenvectors of A, no. Okay. Last, they are asking eigenvectors of A inverse are same, yes. Eigenvectors of any operation on A inverse, A square, A cube, 5A, A plus I, all of them have the same eigenvectors. That sixth property again coming up directly as 2 mark question. ABD. Correct answer shadow. ABD. 3 answers are correct here. Okay. ABD. 3 answers are correct here. Okay. Gate 22 double E 2 marks. Gate 22 double E 2 marks. E power A denotes the exponential of a square matrix A. Suppose lambda is an eigenvalue, V is the corresponding eigenvector. And now consider the following two statements. Statement 1, statement 2. Okay. Which of the following option is correct? Statement 1 and statement 2 are given to you. Okay. E power A is the exponential of a square matrix A, and suppose lambda is an eigenvalue, V is the corresponding eigenvector of matrix A. Now see here. Again I am telling you the same thing. If A has the eigenvalue lambda, E power A, FA will have the eigenvalue E power lambda. Okay. If A has the eigenvectors X, okay, the eigenvector, whenever you create any function of A, the eigenvector remains to be same, only eigenvalue becomes F lambda. Okay. So E power lambda is an eigenvalue of E power A? Yes. V is the eigenvector? Yes. For E power A, eigenvector remains to be V only. Okay. So both these statements are correct actually. Okay. Both these statements are correct actually. Answer is C. Sixth property, very important. Direct, okay, producing question. Okay. Answer is C. Both are correct. Eigenvector remains to be same as X or V, whatever they say. They have told V here, I will write it in the form of V. If it is V, it will also have the eigenvector V, same eigenvector. Got it, guys? Next question. Okay, gate 24, doubly 1 mark question. Okay, what is there? What is the sum of the eigenvalues of the matrix 1, 2, 3, 4 square? Now again you have two choices. Do you need to multiply the matrix and calculate the square of it? Not required. Not required. Okay, that is not going to be required. Okay, sum of the eigenvalue. See, even that can also be done. Okay, what is there? If you do that also, 1, 2, 2 cross 2 matrix only, na? 1, 2, 3, 4. 1, 2, 3, 4 square. Okay, so now what is the first entry here? 1 plus 6, 7. Then first row, second column, 2 plus 8. And that too, not only the first and last will be required, but okay, let me do it. 1, then this is 2 plus 8. This has to be 10. Then 3 plus 12, 15. Then 3 to 6 plus 14, 6 plus 16, 22. Correct? Now let me tally it. 1 plus 6, correct? Then I have 2 and 8, 10, correct? Then I have 3 and 12, correct? Then I have 6 and 16, 22, correct? Now, what are the sum of eigenvalues? Sum of eigenvalues is the trace, which is 7 and 22. This should be 29. This should be 29. Okay. Or otherwise, okay, so 2 cross 2, the product also easy only. Now, what is there? The product also easy. Otherwise, what can be done? Otherwise, what can be done? If I take the matrix alone as 1, 2, 3 and 4. 1, 2, 3 and 4. Okay. Suppose it has some eigenvalues. No need to find the eigenvalue. It has the eigenvalues lambda 1, lambda 2. Not required to calculate fully. Just listen to me. Okay. For the square of this matrix. Okay. For the square of this matrix 1, 2, 3, 4. Square of this matrix, which is known as A here, what should be the eigenvalues? Lambda 1 square plus lambda 2 square, correct? Question is sum of the eigenvalues, na? Lambda 1 square plus lambda 2 square. Can't we use this identity? Lambda 1 plus lambda 2 whole square minus 2 lambda 1 lambda 2. Okay, because when you expand this, a square plus b square plus 2ab minus 2ab, I cancel. Okay, so the answer can be simply written as now. Now, what is lambda 1 plus lambda 2? It is the trace of the original matrix. Okay, trace of the original matrix, 1 plus 4. So, that is square of this minus 2. What is the product of lambda 1, lambda 2? Product of eigenvalues is determinant of the original matrix. So, just substitute determinant 4 and minus 6. Okay, so answer is 5 square, 25. Minus 2 into minus 2, that is plus 4, 25 plus 4, 29. That is also okay. Right? 29. So, the answer anyways is 29. Okay. 1 mark question. Anything you apply is okay here. Easy. Both are easy only. In fact, if you are forming the matrix also, na, you could directly have taken the first row, first column A11, then the second row, second column A22. These two are not required also. But okay, I just completed it, okay. Next question. Gate 21, doubly 2 mark question. Okay, let A be a 10 cross 10 matrix such that A power 5 is a null matrix. For any matrix A, okay, for a matrix A, what is this concept known as first of all? For a matrix A, if A power k equal to 0, for some integer k, then the matrix A is known as a nilpotent matrix. Matrix A is not 0, but any power of A, when you take A square or A cube or something, that gets converted to 0. It is a nilpotent matrix with the index k. Okay, the k is known as the index. But whenever you have a nilpotent matrix, all eigenvalues of the nilpotent matrix are 0. All eigenvalues of the nilpotent matrix are 0. You understand like this also. Why? See, you understand like this. Come up here, yeah. You understand like this. What I am trying to tell you, A has the eigenvalue lambda. Okay, so A power 10 here. What is the question? A power 5 is a null matrix. A power 5 will have the eigenvalue lambda power 5 as per our basic property number 6. Okay, but what they are telling, A power 5 is a null matrix. Now, what are the eigenvalues of a null matrix? Okay, null matrix, all eigenvalues are 0. Null matrix, everything is 0, eigenvalues are 0. That means lambda power 5 must be 0. So, that clearly tells lambda must be 0. This is what I wanted to tell. Okay. So, for any nilpotent matrix, all eigenvalues are 0. Now, the question is, A is a 10 cross 10 matrix. What is the determinant of A plus I? What is the determinant of A plus I? Now, the next point, if A has the eigenvalue lambda, A plus I will have the eigenvalue lambda plus 1. But what will be lambda? 0. Okay. So, 0 plus 1 is 1. That means A plus 1, A plus I, all eigenvalues will be 1. Okay. A plus I, because it's a 10 cross 10 matrix this time, all eigenvalues will be 1. All lambdas are 1. Okay, so question is determinant of this matrix, and again use the point, determinant of a matrix is product of lambdas 1 into 1 into 1 any number of times. What I have just used is determinant of the matrix is nothing but the product of lambdas. Answer is 1. Answer is 1. So, not only A power 5, any A power k equal to 0 for the matrix A, the matrix is nilpotent matrix. Okay, and all eigenvalues of a nilpotent matrix as well as a null matrix are 0. Okay. Next question. Yeah, gate 23 EC 1 mark. See, this is indirectly related to diagonalization concept, but you can still solve it normally. Okay, just see how you can solve this question and give me some answer. Yeah, let's do it. Let the sets of eigenvalues and eigenvectors of the matrix B be lambda k, k is 1 to n, and Vk, k is 1 to n. That means lambda 1 to lambda n and some V1 to Vn. This is the set of eigenvalue eigenvectors. For which matrix? For B. For any invertible matrix P, the set of eigenvalues and eigenvectors of the matrix A, where B equal to P inverse AP respectively are. Okay, diagonalization concept, but okay, let's solve it normally. What they are trying to tell you is there is some matrix B, it has some eigenvalue lambda, some eigenvector V. Lambda 1 to lambda n, let me call it as one eigenvalue lambda and one corresponding eigenvector as V. Okay, now we need to find the eigenvalues and eigenvectors of the matrix A. Okay, where B inverse is P, B is P inverse AP. So let me first write down this relation like this. Okay, multiply both the sides by P. Okay, pre-multiply by P. So PB will be equal to AP. Can we write like this? PB will be equal to the AP. Okay, multiplied here by P. Okay, so this P inverse will cancel. Only AP will be left. Okay, now when you are telling B has eigenvalue lambda, eigenvector V, what should be the relation? BV equal to lambda V. AX equal to lambda X relation. So BV equal to lambda V. Okay, BV equal to lambda V. Now what to do, dear? Multiply both the sides by P. Multiply both the sides by P. So P into BV equal to P into lambda V. Lambda is a number, na? Multiply P with the matrix, P matrix with the matrix V, with the vector V. So what do you have now? I want the result for A, na? I want the result for A, na? What is P into B here? Okay, what is P into B will be A into P. Okay, so the left side can be written as A into P into V equal to lambda into PV. Lambda into PV. Now you see here, see the relation very carefully. A into PV is equal to lambda times PV. Okay. Or let P into V equal to some vector X. Okay, what is the relation now? AX equal to lambda X. A clear eigenvalue eigenvector relation. So what is the eigenvalue for matrix A? Is lambda only. What is the eigenvector? Is P into V. Okay, option. Eigenvalue will remain as lambda. It will not modify as lambda into something. But eigenvector will modify as P into V. Okay, what is that X? P into V. Okay, the correct answer, C. Those of you have completed diagonalization of matrix, this is a concept related to P inverse AP, the diagonalization concept. Okay, but anyways, we have solved it by a normal eigenvalue and eigenvector logic as well. Okay, any doubt? Please let me know. Any doubt? Okay, you can further let me know. What is there? CS 2 mark question. Gate 21 CS 2 mark question. What is this? 0 triple 1 1 0 1 1 1 1 0 1 triple 1 0. Okay, there is a matrix given. What is the largest eigenvalue of the above matrix? Okay, you have a 4 cross 4 matrix given. You have a 4 cross 4 matrix given. Now see, can we write down this matrix? See, all elements are 1 except diagonal. Na? All elements are 1 except only diagonal. Okay. If you add onto this matrix, if you add a identity matrix, now identity matrix will have only ones in the diagonal place. And when you add identity matrix, what will you get? 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1. All elements will be 1. Okay, suppose this is some given matrix A. I want the eigenvalues of A or largest eigenvalue. Okay, and when you add A plus identity, you get the matrix B. Okay, which is in front of you. Okay, which is in front of you. Okay, can we talk about the rank of this matrix? All rows are proportional, only one independent row. Such questions we have solved already. When all the rows are proportional, rank of the matrix is 1. All rows are proportional means only one independent row, R1. R2 is R1, R3 is R1, R4 is R1. So rank is number of independent row which is equal to 1 here. Okay, the rank of this matrix will be 1, no doubt. Okay, so rank of the B matrix is 1. Now one property where I told you the relation between rank and eigenvalue. Question is actually eigenvalue. Rank is number of non-zero eigenvalue. Okay, rank is number of non-zero eigenvalue. So, number of non-zero eigenvalues of B will be only 1. In some of the property list I have shown you, rank is number of non-zero eigenvalue. Yes. So, number of non-zero eigenvalues of B will be 1. Okay. So, B will have how many eigenvalue? It's a 4 cross 4 matrix. Okay, it should have 4 eigenvalue, but it will have only one non-zero eigenvalue. That means for B, what are the eigenvalues? Only one non-zero and rest will be 0. Only one non-zero, rest will be 0. Okay, suppose that one non-zero eigenvalue is lambda. Only one non-zero. Okay, rest will be lambda zeros. Okay, suppose that one non-zero eigenvalue is lambda. But what is that lambda? Okay, lambda plus 0 plus 0 plus 0. Sum of lambdas should be trace of the matrix B. Okay, what is the trace of the matrix B? Sum of the diagonal elements. All diagonal elements are 1. So 1 1 1 1 4. Okay, 1 1 1 1 4. So the lambda is 4. Okay, now come to the answer here. Okay, what is the A matrix? I don't want the eigenvalues of B. Okay, what is the A matrix? The question says find the eigenvalues of A matrix. A matrix is but nothing but B minus I. Okay, A matrix is B minus I. So if B has the eigenvalue lambda, A will have the eigenvalue lambda minus 1. Again the sixth property coming into action. A will have the eigenvalue lambda minus 1. So now lambda starts with 4. So 4 minus 1, 3. 3. And then others were 0. So 0 minus 1, minus 1, minus 1, minus 1. 3 and minus 1, minus 1, minus 1. Okay, the largest eigenvalue, fill the answer here. The largest is 3. The largest is 3. In fact, I can give you a tip now. What is the tip? Whenever you have the matrix, okay, which contains all ones, whenever you have a matrix which contains all ones or all rows are proportional, suppose it is n cross n. Okay, two things to note here. Rank of this matrix, whatever the size it is, rank will be 1 only. And second point, what will be the eigenvalues of it? Rank is number of non-zero eigenvalues, so only one non-zero eigenvalue. Okay, only one non-zero eigenvalue. Rest will be zeros. What is that one non-zero eigenvalue? Sum of eigenvalues lambda equal to trace. Trace will be 1 1 1 1 1 n times n. So eigenvalue will be n and all zeros. So if there is a matrix filled with all ones, the eigenvalue of the matrix will be n and all zeros. The rank of the matrix will be 1. Okay. So like here it was 4 cross 4, so we got all the eigenvalues as 4 and 000, 4 and 000. Okay, so for the current question, answer was the largest eigenvalue required, so that is why 3. Okay. Tell me any doubt in this question. Okay. All right, next question. Let X be a n cross 1 real column vector with the length L equal to under root X transpose X. What is the trace of the matrix XX transpose? Now, a basic question on trace and determinant, not on eigenvalues, but this is something, that will be useful in many questions. So let us understand this question very carefully. Let us understand this question very carefully. Okay. Right. No break as of now in between. If you want, you can have refreshment parallelly. Okay, but you should not leave the session. Parallelly, you can have something, tea, coffee, snacks. Let X be a n cross 1 real column vector. Okay, with length under root X transpose X. Now, what is the meaning of this? X be a real column vector. Okay, and n cross 1 in size. What is the X I can take? Understand. What is the X I can take? Column vector. Okay, how many rows? N cross 1, so n rows, it means n entries, x1, x2, etc. up to xn. This is how you can define a n cross 1 real column vector. All entries must be real. Okay. What is the length of the vector is given by under root X transpose X. Okay, that is the general way to write down the length. You should understand again. Okay, what is the length of the vector is given by X transpose X. Okay, under root X transpose X. So first let me show you what is the X transpose X meaning. X transpose X is again a dot product calculation. Okay. But no problem, let me show you here. X transpose will become x1, x2. It will convert to a row, column will become row. Then multiply x1, x2, etc. up to xn. Now when you open it, first row, first column, x1 square. Okay, the first row, only one row, one column. Okay, so x1 into x1, x1 square. Okay, then x2 into x2. Corresponding elements will multiply x2 square. Next should be x3 square, and this will happen up to xn square. This is what is the formula for. This is what is the formula for length square. Normally in the vectors also you find the length like this. So that is why the length has been told as root over X transpose X. Okay. Like if I give you a normal vector xi plus yj plus zk. Xi plus yj plus zk. How do you find out the length of the vector, magnitude of the vector? Root over x square plus y square plus z square. Root over x square plus y square plus z square. Vanakkam Balaji. That is what is given. Now the question is, what is the trace of the matrix P which is XX transpose? What is the trace of a matrix P? What is the trace of the matrix P which is equal to X into X transpose? Okay, what is going to be this X into X transpose? Now X is a column vector. Understand carefully. Okay, now multiplying by its transpose x1, x2, etc. up to xn. Now when you multiply, this is going to be a n cross n matrix. See how? Okay, first row, first column, only x1 into x1. Finish. First row, second column. Now you go to second column. Okay, x1, x2. Now third column, x1, x3. Till you go to the last column, x1, xn. Then next, second row, first column. x2, x1, x2 square, x2, x3, till x2, xn. What will happen next? Next you will have x3 here. So x3, x1. I'll write down the third column also. x3, x2, x3, x2. Then x3, x3. You will have x3 square. Till x3 multiplied by xn. And you do till the last row, xn into x1, xn into x2, xn into x3, till xn into xn, xn square. Till xn square. Okay. Now the question is trace of the matrix. Okay. Any observation on this matrix? You see, this is what is going to be the diagonal entries, but the elements above and below the diagonal. Okay. Diagonal, if I want to separate also, this is what will be the diagonal entry here. Okay, but x1, x2 is same as x2, x1. x1, x3 is same as x3, x1. x2, x3, x3, x2. x1, xn, xn, x1. x2, xn, xn, x2. x3, xn, xn, x3. Everything is same. Okay, everything is same. So what is happening is the matrix P turned out to be symmetric matrix. Always, dear, okay, x into x transpose will be symmetric. Now come to the main question. What was the question? The question was trace of the matrix P. Okay, trace of the matrix P is sum of the diagonal entries. Okay, the sum of the diagonal entries is nothing but x1 square plus x2 square, etc. up to xn square, and that will be nothing but length square, because this is what I've written as L square. L is under root x transpose x. Okay, so it is coming up as L square. So correct answer, the trace of the matrix is equal to L square, option A to be tick marked. A question only on trace of the matrix, but decent question. And then in GATE you will find questions around this concept of matrix XX transpose, where x is a simple vector, x into x transpose based question. X into x transpose based question. The PDF you are going to get in my Telegram group. Okay, I will share you the link also at the end. Okay, I will share you the entire PDF. Okay. All right. Chalo, next question. Now you see a GATE 22 EC 2 marks question. Okay, have a look into this. You can search by my name, or I'll just update the exact name. Just wait for it. Let alpha beta be two non-zero real numbers and v1 v2 be two non-zero real vectors of the size 3 cross 1. Suppose that v1 and v2 satisfy v1 transpose v2 equal to 0, v1 transpose v1 equal to 1, v2 transpose v2 equal to 1. Let A be a 3 cross 3 matrix. It's actually a good question, but you can solve by simple logic. Okay. Let 3 cross 3 matrix be given by alpha v1 transpose plus beta v2 transpose. Now you see v1 transpose, it's just like the term x into x transpose. It is just like the term x into x transpose. A very simple logic I will just say to finish the question. Okay, what is the trace of the matrix A? Rather than forming the matrix A, which will be time consuming, what is the trace of the matrix A? Trace will be alpha times the trace of this matrix. What is the first one coming? v1 transpose plus beta times the trace of this matrix. What is the other matrix? v2 transpose. Okay, but for any x into x transpose, I just have calculated and shown you, for any x into x transpose, what is the trace? Trace is given by L square. L square means x transpose x. Correct na? Correct na? Let us use this simple point. So this is going to be alpha into trace of v1 into v1 transpose means v1 transpose v plus beta trace into v2 transpose, x into x transpose trace is x transpose x, v2 transpose v2. Okay, v1 transpose, now see here, v1 transpose v1 is 1, v2 transpose v2 is also 1. Both of them are unit length. Okay, both of them are unit length. So this becomes alpha into 1 plus beta into 1, and that is alpha plus beta. Correct? Yes, actually very correct, Tirumila. Both the vectors are orthonormal, but not required. That concept I've solved by a simple logic. See, both the vectors have unit length and they are perpendicular to each other. Okay, so the two vectors which are orthogonal and also having normalized length, unit length, are orthonormal vectors. Correct? Orthonormal vectors. Okay, but what is my answer? The trace of the matrix should be alpha plus beta, and trace is what? Trace should be sum of the eigenvalues. So whatever option is correct, lambda 1 plus lambda 2 plus lambda 3 should be trace of the matrix alpha plus beta. 3 eigenvalues, na? 3 cross 3 matrix is there. Okay, but only which option satisfy this? Okay, B will fail, D will fail, C will fail, only option number A. Only the option number A. Only the option number A. Okay, no need to form the entire matrix. Okay, because that's actually going to be time taking, not required. Okay, That's it. So option number A, 0 and alpha beta, because sum of eigenvalues has to be trace, and trace I have calculated alpha plus beta. Trace has been calculated as alpha plus beta. Okay. All right. Now gate 22 civil 2 marks question on the similar thing, y transpose and y transpose y. This one good question. This one good question. Rest anyways we have solved. This one good question will be a homework for you. Okay. Again remember that y is a non-zero vector of size n cross 1. 2022 cross 1, because the question was framed as 2022. Okay. Y is some n cross 1 vector. Okay. Remember y transpose. Okay, y transpose, just the question previous to it. Okay, y transpose is a symmetric matrix. Already I have shown you. Okay, so what is y transpose? What is the rank of that? Okay, or what is the eigenvalue of that, trace of that? All that I have explained you. Just think about this. Okay, y transpose, solve it just like xx transpose, which is symmetric. But you know, whether it is invertible or what is the eigenvalue or what is the rank, just solve and get me the answer. Just solve and get me the answer. This is one good question, MSQ. Okay, please mention your answer in the comment box later. Okay, once you solve it, please mention your answer in the comment box so that let others also comment, and then you can compare your answers and I will reply with the correct answer. Okay, rest most of the good questions you have solved. Just one good question I want to leave to you so that you also open your thought process and start solving it. Question MSQ. Okay. All right. Okay, I guess you will do it. Any confusions you can let me know right now only. Okay, now, okay, this was the question on Cayley-Hamilton. I have already taken it earlier. This was done. Here it is, Cayley-Hamilton. I already told you this was also Cayley-Hamilton based question done. Now, gate 21 EC 1 mark question. Gate 21 EC 1 mark question. Given the vectors, okay, 3 vectors in R3, you know, you should know what is R3. It is the set of all real vectors which are of the size 3 cross 1. Similarly, we have Rn, set of all the real vectors, R for real and the 3 for dimension, the 3 for size. So, you know, of the size 3 cross 1, all real vectors, the set of all real vectors. Now, if these 3 vectors are linearly dependent, the simple way of solving this question, which is also related to the concept of, you know, basis. Okay, so you know, this is only EC. See, this question is of course EC, but this can be a generalized question. Any branch student can watch it. Why? Because what is the meaning of these being these 3 vectors? Suppose x1, x2, x3, whether they are dependent or independent. See, simple logic. Form the matrix A. Okay, form the matrix A where the vectors are arranged in the columns. Okay, C1, C2, C3. Okay, arrange the vectors as the columns of a matrix. Okay, arrange the vectors as the columns of the matrix. Okay, and if they are dependent or independent, rank or determinant can be used. Now, this current question, the matrix will become 3 cross 3 because all the vectors are having 3 elements. Okay, the matrix will be 3 cross 3. Okay, the vectors will be linearly dependent or independent based on the determinant of the matrix. What can you say? If the determinant of the matrix is 0, somehow the columns are dependent. The matrix has dependent columns or dependent rows. Then only the determinant is 0. Okay, that means the vectors also x1, x2, x3, which are the columns. Okay, they are said to be dependent. But if you get by chance the determinant which is not equal to 0, okay, that means the columns are independent. The determinant is 0, so that means the matrix has independent, linearly independent columns. Okay, and columns here are x1, x2, x3. x1, x2, x3 then will be known as independent. Okay, so what is the matrix A for the current question? I want to form the determinant of A. Okay, so A will be 1, minus 1 and 2. You can arrange as row or column anything. 7, 3 and this becomes x. And what is the last one? 2, 3 and 1. Correct. What is the determinant of this? Okay, if they are linearly dependent. So what you want? If they are linearly dependent, you want determinant equal to 0, correct? You want determinant equal to 0. Now I'll just form the determinant 1 into 3 minus 3x minus 7 times minus 1 minus 2, 3, 6, correct, plus 2 times minus x minus 6 is equal to 0. Okay, so 3 minus 3x minus 7 plus 49 minus 2x minus 12 equal to 0. Okay, so 2x, 3x, right side 5x, the other terms are 52 minus 12, 40, x equal to 8. Now, whether the vectors are dependent or independent, such a question, although important for EC, but such a question can be there in any branch. This has no, this can be an independent question also. Yes, Tirumala, x equal to 8 is the correct answer. Okay, but now a question related to it. Now for EC students, the vector space and basis, for which I have already uploaded additional video, you can watch it, is an important topic, only EC, vector space and basis. Okay, because I am not going to cover it here fully. Okay, in the past 5 years, so probably this is the only question directly that I could find. Okay, but otherwise 2020 itself, since I have taken the question from 21, in 2020 itself, there was a very good question from vector space and basis. You must go through it, all EC candidates. Otherwise, you can go to an entire video which I have uploaded on vector space and basis. Very important for EC, very helpful. Okay, let R and R3 denote the set of real numbers and three-dimensional vector space. I already told you the meaning of R, R3 or Rn. What is the value of alpha for which the set of vectors does not form a basis? A set of vectors will form a basis, okay, if they are linearly independent. So a set of vectors do not form the basis, okay, do not form the basis if they are linearly dependent. They do not form the basis if they are linearly dependent. Okay, they will not form the basis if they are linearly dependent. If they were linearly independent, they are said to form the basis of R3. Okay, right. One simple point I will write down. Three vectors, or in general, n vectors can form a basis of Rn if they are linearly independent. If they are linearly independent. Okay, but here they do not form the basis, so the given vectors must be linearly dependent. Then what is the method I just told with the previous question? Okay, that means the determinant of the matrix A, if I form here 2 minus 3 and alpha, 3 minus 1 and 3, 1 minus 5 and 7, this should be 0. Correct, 2 minus 3 alpha, 3 minus 1 and 3, 1 minus 5 and 7. Okay. Right. So when I solve for the determinant, I'll get minus 7, minus plus 15, then minus of 3, minus 21, plus 5 alpha, this was minus 21, and plus 1 into minus 3, minus 9 and plus alpha, this must be 0. So this is 8 to 16, minus plus 3 into 21, 63, minus 15 alpha, minus 9 and plus alpha, this must be 0. So how many alpha on the right side? I will write down 14 alpha, and what is the rest calculation left? 63 plus 16, 79, minus 9, 70. Okay, so 14 you divide, alpha will be 5. Please check the calculations. I am getting alpha as 5. Yes, Tirumala, correct answer. Got the alpha as 5. So this is a direct question on the concept of vector space and basis. You can get good question also, but this is what was there in the 21 to 25. One is direct statement, linearly dependent or independent. This can be a question to other branch also, but this question where they use the word vector space and basis has to be EC specific. Okay, but for EC students, I suggest to go through this topic because you can expect the question. This is only in EC syllabus, vector space and basis. You can expect some other conceptual good questions also, so you can go through this topic separately. Okay. All right. What else? Done. All PYQs done. I think it's more than 3 hours of the non-stop session. It's almost 2:30 p.m. Okay, guys. So now important point is 10th January is nearing. And on the 10th January, okay, Om Institute brings to you, okay, a feel of the gate exam. Yes, experience the gate before the gate by appearing in our All India free mock test. Yes, appear in the All India free mock test coming on 10th January, this Saturday, exactly at 9:30 a.m. Why? Because this test is for EC and EE aspirants only, and for both EC and EE aspirants, the exam, Okay, the GATE exam this time is on forenoon session. Electrical 14 February 9:30 a.m. EC 15 February 9:30 a.m. So we want you to appear exactly on the same time so that you get the real exam feel on the exam scheduled time. Now, this exam is conducted roughly 35 months before your actual exam, so that based on your performance in this mocks, you can decide your next 1 month or 35 days strategy, which subjects you're strong or good at. Okay, how, easily you were able to do the time management, whether you were able to have that on-screen focus for 3 hours, what was lagging for you, whether patience or whether pressure was so high for you, okay, or whether that screen was a disturbance for you. You will learn many things. So definitely appear, and if you really come out with good numbers, definitely it will boost the confidence, and going into the last 1 month with confidence is extremely good. But even if you don't score, I think it is better, because you will come to know why you don't score better. So you will analyze your mistakes and you can decide your next 1 month on the basis of that. Lot many things can be learned, and if you really perform, there are exciting prizes, okay, for the top 5 rankers, okay, of this online free mock test. Okay, so the registration is free. Just register. Registration link we will attach in the description of the video as well, and appear on this very important mock test on 10th exam. And over an important one more thing, because several students will be appearing, you also get to know your all India ranking and all India performance. Okay, so yeah, that's it. Now guys, if you want to also have a quick assistance in revision, get a quick revision of all concepts, and also focus on problem solving capability, so the Om Institute online free, online recorded crash course, it's not free, I'm sorry, it's available on the app. Okay, you can go to the app and get all the details there. Online crash course pre-recorded manner is available, which can help you to revise entire content in a quick manner of time with all key concepts and more importantly problem solving capabilities. Okay. And guys, if you are planning to prepare, or if your juniors are planning to prepare for upcoming GATE exam of 2027 or 28, the Om Institute announces the first online live course, which starts 2nd February. Yes, the first online live course starts 2nd February, and the fee for 1 year and 2 year validity, that is for GATE 27 or GATE 28, are respectively mentioned. The platform will be Om Live app, but if you register till 10th of January, okay, you get a 20% discount on this fees and a 2 months extra free validity. Like for 1 year course, it will become 1 year plus 2 months, 14 months. 2 year course will become 2 year plus 2 months course, right? You just have to use the code OHM GATE 20. Thank you. If you are also planning to prepare for AE, or if your friends or colleagues are planning to prepare for AE, you can update them that the new offline batch just started 3rd January at the Om Institute Offline Center at the Hyderabad. Okay, so for AE, any of the exam of AP, Genco, Transco, Discoms, or Telangana Transco, Discoms, or Genco, okay, you can join this course and get excel in the AE exams as well. All right. Now guys, important thing, as you know, I will share you this entire PDF, which has 5 years PYQs with detailed solution, with revision of the important points, bullet points, properties, some theories also there. So this PDF will really help you in revision. So I will share you this PDF in my Telegram group. You can search by this name. Okay. So as a standard rule, standard procedure, all my PDFs are always password protected. And what is going to be the password of it? Okay. What is going to be the password of it? The password for today's PDF, what comes into my mind randomly? What comes into my mind is Eigen. The password for today's PDF is going to be Eigen. E-I-G-E-N. The password for today's PDF, make it as Eigen. Okay, based on many questions on Eigenvalue, Eigenvector, everything in small. Everything in small, no space. Please note it correctly, E-I-G-E-N, Eigen, everything in small. Okay, this is what is the PDF. PDF is always password protected, so that those who have, really learned from the video, the PDF is helpful only for them. Okay, you have spent more than 3 hours on the session. Okay, you deserve this PDF. All right, guys. So bye-bye. Thank you. Stay safe. And yeah, we'll plan many more sessions, and probably I'll tell you, tomorrow or day after tomorrow, in next 1 or 2 days, a very important thing for electrical, you are going to get the PYQ sessions on power system and power electronics. Stay subscribed to the channel. That is why I say, if you're not subscribed, subscribe immediately so that you don't miss any of the fruitful sessions. But I repeat, probably tomorrow or by day after tomorrow, in next 1 or 2 days, you will get the core PYQ based session, power electronics and power systems as well. And very soon, Surendra sir will continue with the electrical machines top 100 questions he started. He will take the next session onto the same series, part 2. Okay. So this is Rakesh Talreja signing off. Bye bye. Thank you. If you have really watched the session patiently and got some knowledge, do not forget to hit the like button. That's just like a small attendance. Okay. And if you again want to attend all the sessions without a miss, subscribe the channel. Thank you. Stay safe and take care of yourself.